unbeatable. Will no one stop this man? To be fair, I think Jed got it yesterday, but... Alright. We're here. And I've been debating if I want to even try getting questions off Reddit. I really... I mean, you know, let's at least try. Let me, bring up the old Opera browser. Oh god. Let's see. Hey, Yanis. Dear Misery, you can't stay for long now? Ah, alright, Spetri. Well, I mean, you did the most important thing, which is getting first. Oh. What if I don't want to load the full resolution? Will you get out of my way? What? Why would you put it in the middle of the picture? Okay, I'm sorry. I'm 3 minutes into my stream and I'm already raging at the internet. You might pop it in later on? Okay. Sounds good, Spetri. No worries if not, of course. This looks terrible. AB is parallel to CE and the rest of it is as you see in the figure. You have to prove CG equals GF, CG equals... Oh my god! I don't want to do this. I'm not... and I don't have to do this. That looks terrible. I don't know how you do that. What? Go away. I didn't ask you to pop up. Boss. Yo. And as an answer, that's why I have not been even trying to get questions off the internet, because it's just so lame when everything is already answered. Which, I mean, it's good for the people who are asking the questions, but, like, what do I do? If I were to ask math, there's nothing there, then I'm just going to go to the abstract algebra book. What? Drawing with perspective? No, I'm okay. I don't know how to draw. I barely know how to write. Given that sine of 50 equals b, express each of the following in terms of b. Wait, what? Really? Given 4 to the n minus 3 to the k equals 1, so that n equals k equals 1. So basically that's the only solution, is if they're both equal to 1. I mean, it makes intuitive sense just going through the first two powers of 3 and 4. I can't think of any other pair that are just one apart. How would you solve that? Like, you could solve for n in terms of k, and maybe try and plug it back into the original equations? That seems kind of weird, though. I feel like you just get some stupid statement. I think like negative powers are surely right out. Because the numerator is always 1, so there's not much that you can do there. Yeah, I don't know how you prove that there isn't a solution for n and k greater than 1. Or it's not both equal to 1. Probably involves some kind of mod rule, but it's like a double mod, so I don't really know how that works. Oh, I thought this was a multiple choice question. A, B, C, and D. I was like, sine 230 is certainly not sine of 50. I don't really know how you do that, Yanis. How do you express sine of 230 in terms of B? It's an annoying angle to be given. I don't want to look at the picture like too much. I guess that's what, 180 plus 50? That's not unit circle. Maybe it doesn't have to be. But go the hell away. No one asked you. I don't know why I always yell at things that the computer does when I mean, maybe it can't hear me if I'm being spied on or something, but... Okay, 230 is right there. It's not particularly relevant. We have sine of 50, which is over there. And we come all the way around by 180, which is just negative b? Because sine of itself plus 180 is the same thing as negative sine, a sine of that negative thing, which is also negative sine of that original thing. Negative b. Okay. What's this person actually asking? Am I overthinking this? Oh, that's on part C. Still make sure that we're on board with what's happening here, though. So cosine 50, I mean, I guess I gotta... I saw that they draw a right triangle. Is there a different way to do it? Like, because when I first saw cosine of 50, I was thinking you have to use the cofunction identities, if they're called that. Like, sine of 50 is equal to cosine of 90 minus 50, but that's not b. Yeah, I mean, I guess you would have to draw a right triangle there, because it's the same angle. Say, just Pythagorean theorem and root 1 minus b squared. Okay. We're asking about part C, though. Oh, I get it. Because, yeah, if you have tangent of 40 degrees, that's basically the other right angle of that same right triangle with a 50-degree angle. This person swapped the angles, which I'm not a huge fan of. That's maybe it's right. That like maybe you get to the right answer. That feels sketchy to me. Like it's a potential like gray area. I guess as long as they switch the sides, also it doesn't matter. So I think tangent of 40 is what could be like b over root 1 minus b squared. I had it flipped. But yeah. Basically this. And I think the person said they switched to the angles, which is fine as long as you switch these two sides as well. Because it still has to be true that sine 50 is b. So as long as that's still true, then I think you can switch the angles all you want. Um, then going to part D, it's like we had before, where you add 100 degrees, which isn't a nice value. Is that in the song or in real life? Oh. It's like this annoying, like, ringing noise, and I thought it was the song being annoying, but no, it's some annoying sound in real life. Why is my mic up? Or why is my mic down? Let's put it up. Yeah, if you know... Oh, you know what's going to be? Tangent of 140 is going to be right here. And since it's a 40 degrees down here, it's going to be 50 degrees up here. So you can still make a 50-degree, like, right triangle. And if... that means that B is going to be up here. No, how does that right triangle look, though? It's still tangent of 140. Is it going to be just a negative version of what we just did? It is. I have a hard time explaining why, though. Yeah, okay, so this is the exact thing that, like... maybe the... because I was thinking you make a right triangle from here over to the y-axis. But I guess you could also, like, make the angle down to the negative x-axis and just have B be down here. And I guess you get the same answer. Yeah, okay. Hey, Jed. It's like geometry. It's more trig. But trig is also like, you know, fancy geometry. I think I've gotten to the answer here. Just working this stuff out in my head, but they gave you that sign of 50 degrees is equal to B. They want you to express each of these in terms of B. The person in particular is asking about C and D. Close enough? I feel like the music's a little hot. Let me turn it down slightly. That seems like a better level for it. Did I? Okay, good. This is... okay. I'm using a YouTube video for the music right now. High five, there we go, the 5-watch streak. So yeah, tell me if the music starts stuttering again. I'm using just Firefox in a YouTube video this time, which I don't normally use. I'm working on the music stuttering issue, but it seems like it's an... like I did a bunch of Googling on it. It's an issue with Windows that they're like that the OBS people have notified Microsoft of, and they're just waiting for Microsoft to do it, which maybe tomorrow or maybe never. So I'm working on some kind of like workaround, but it's kind of complicated to like route my audio. Like I'd always have to insert another program to route the music into that and then into my OBS. Which I tried to do, but it's really annoying. So I'm going to figure out hopefully my 2 off days here. For the tangent, you're using the 90/40. Yes, exactly. So the person, I think like for part C, they're asking if it matters if they flip things, which it doesn't as long as they're consistent that sine of 50 is B. It's all the same triangle. What are they asking about for part D, though? I haven't quite figured it out. I think they're really kind of asking the same question here, which is fine. The leg lengths. I think I used that without really thinking about it. I'll show the answer he said. I kind of did it in a slightly different way. Like I drew the triangle. So this is the book's answer key. I drew the triangle from this S point over to the y-axis. And notice that this is a 50-degree angle right here. And I did the tangent of that angle, which kind of sounds wrong now that I say it out loud. The book makes the other right triangle, which is from S down to the negative x-axis. Oh, they do that. They do. They do that identity, but you have to compensate with a negative sign because tangent is negative in the second quadrant. I think what I just said is wrong. I think you do make the right triangle from S down to the negative x-axis. And that means B is this length down here, and root 1 minus B squared is this length right here. So tangent is opposite this over B that, and this is a negative distance down here, so you need a negative sign. Okay. Calculations. And just remember which quadrant you're in. As long as you remember which quadrant, actually, as long as you remember which quadrant you're in and whether you expect a positive or negative answer. Yeah, I think they did that too, Jed. More or less. Hey, Milk. Is fx equals x sine x uniformly continuous on the reals? Just kind of curious what people are saying. Yeah, x sine x wouldn't be bounded, would it? Hmm. Really? I forget, like, uniform continuous is you get to choose one delta and it works for literally any epsilon you want. I feel like this shouldn't. But I may be misremembering how uniform continuity works, so. All right, yeah, I'm gonna, I think go with the abstract algebra book, because it's really annoying to get questions off the internet. uh, you don't think it is? F prime is sine x plus x cosine x, which is unbounded. That was my thought, Yanis, but it's, okay, I mean, okay. Well, let's look it up since it sounds like you've at least taken an interest in it. What does it mean to be uniformly continuous again? Because the person who responded saying that you could potentially bound a difference in y values, which seems reasonable. But I don't know if that's relevant to the to the idea of uniform. Oh, maybe it is. Okay. Literally the first thing I see is a difference in function values. Let D be a non-empty subset of R if a function f maps D to R, or a function f that maps D to R is called uniformly continuous on D. If for any epsilon greater than 0, there's a delta greater than 0, such that if u, v belong to D and u minus v is less than D, delta. Am I is this a different? This isn't uniform continuity as I remember learning about in Zach's class. It might be my own faulty memory, or it might be an equivalent definition that's phrased differently. So if you're given any two values in the domain, well, what? You're given an epsilon greater than 0. You're interested in the distance between two of the function values. And you can choose. Is it just saying it doesn't like change that quickly? Like it almost like a rate of change thing. Given a delta, you should be able to move to the right in the graph, and at some be really steep and should no longer satisfy the bound. Okay, so yeah, your delta is like the width of the, it's like you're taking like a horizontal width, I guess is a horrible way of describing it. And you can move that same width like left and right on the function as much as you want. But you have to be able to find somewhere where that vertical change is within a certain bound. If the derivative is bounded, the function is uniformly continuous. But don't quote me. I will quote you, Yanis. Just following orders. It's a normal definition? Okay. Let me, oh man, I don't remember which meeting was. Can I quickly find, yeah, I think one of the examples we were looking at in the real analysis class was square root of x? Oh wait, square root of x is uniformly continuous, but the derivative is unbounded. I don't know what 1 over 2 root x looks like, I guess. Where were these things saved? Here. I should really get these in a folder. These problem sets. I also mean to go through Discord and download all the images of the problems that we did. I think it's earlier. 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 Uniform continuity. Okay. Problem set 12. I need to bring it up in a different browser though, because Opera doesn't do PDFs for some reason. So let me... This is the same definition. The cube root of x is uniformly continuous. Oh, for any pair xy. That, okay, so you can't just arbitrarily, like, slide. You should be able to do that, but you can't choose a particular one. Wait, no, there is a... Well, I'm getting confused on... I feel like I understood this when I looked at this question when it came up in class. Now I feel like I don't understand it. Any xy pair within that delta that you choose. Like, are we choosing the xy pair or not? That's why I'm confused on, I guess. Like, if all we choose is the delta, it's for all pairs. Okay, so yeah, so for any pairs, you know, if your delta is like 0.1, then it has to work for any pair of points that are within 0.1 of each other. And you have to, I guess, you know, do that sliding left and right thing and verify that it does meet it for all of that, like that width of the interval. Hey, SPQ. And so yeah, for x squared, of course, you can keep on moving to the right or to the left, and eventually you're going to break that bound because you're just growing too quick. Whereas cube root of x, it's growing like, you know, pretty fast in a bounded area, you know, just around 0, and then it levels off a lot. So as long as you're covering that, like, quickly growing area around 0, 0, you're fine. Okay. So now I feel like I have somewhat of an understanding of uniform continuity. Let's go back to this person's question. Hey, DS. Lurking in the background. I appreciate it. And I feel like there's no way x sine x is uniformly continuous, right? I don't feel like it will be. Maybe it is. Like y equals x is uniformly continuous. So would x sine x change things that much? Maybe it is uniformly continuous. Go. I don't know. I guess the peak in the valley, if you're given, no, I feel like it's not, because it's going to get steeper and, oh, no, the steepness is always the same, maybe. Or is it? Because the period is always the same. No, the steepness does increase, because you have to go from, you quickly have to go from a higher y value all the way down to a lower y value, and that distance increases. So you do have to get steeper here, I think. Which I think would imply that it's not uniformly continuous, right? Yeah, but the frequency is always the same. Like, maybe if the frequency was getting longer. I guess x sine 1 over x would be a little weird though, but the function is changing. Oh, it's like for a fixed frequency, your change in y is getting higher and higher, so you must have a steeper and steeper slope. I guess we could graph the actual derivative of it too. It's sine x plus x cosine x. This doesn't tell me that much, to be honest. Other than the derivative is also doing basically the same thing. I just Google this. I want someone to tell me the answer. X sine x uniformly continuous. Okay, yeah, of course sine x is uniformly continuous. It's like delta equals 2 pi. Is that actually... Oh, no, never mind. You don't choose. I think you just choose a constant delta if sine is always bounded, but maybe not. But I want x sine x, right? Not uniformly continuous. Okay. So this is just for continuity. For all epsilon greater than 0 and for all y, there exists a delta such that x minus y is less than delta and x sine x minus y sine y is less than epsilon. How does q equal p? Isn't it saying x equals y? This line makes no sense to me. Let's see where it's going. I wonder if that's typo. They mean. Okay, this person's asking the same thing. Yeah, it's probably a typo. Just q equals y plus 2 n pi. Okay, so this is naming an xy pair that is within the delta bound, but out of the epsilon bound. Okay. Because of course when you subtract x minus, or when you do x plus 2 n pi minus y plus 2 n pi, you get just x minus y is still less than delta. But by adding the 2 n pi for an arbitrary, you just always find a big enough n where your fluctuations get bigger, like bigger and bigger. The sine of x plus 2 n pi is just sine of x, same over here with y. And then it looks like they factor out the 2 n pi and group the sine x and the minus sine y. So yeah, this matches the original, but it's plus an extra value here that grows without bound depending on what you want to choose for n. So you can certainly break the epsilon bound. Okay, that's kind of a neat way of showing it. Now I kind of look back at just sine x. I understand why that is uniformly continuous, because they said it was just epsilon over 2 and doesn't depend. Like I was looking at like the conclusion of this one, but I want to follow the work. Oh my gosh. That yawn came out of nowhere. Drink my coffee and everything. I assume there's a less than epsilon that should be over to the right here. I think it's just using a trig identity. Oh no, this is... What? Okay, this uses a trig identity to go to that, and then... You somehow know this? What? Okay, it's using this... Those sum to products. We have sine x minus sine y. You're taking some absolute values. So normally they're equal to each other. They're saying less than or equal, which might have something to do with the absolute values here? some theorem that you don't know what it is in English. Sine x minus sine y is less than or equal to x minus y times 1 is less than delta is equal to epsilon. So, I'm going to write 1 for cosine? Okay. I think that's the mean value theorem that the person on Reddit was referring to. Like, you're talking about... That's Rolle's theorem. You're talking about this one right here, I think. I mean, I guess you're really using this form of it down here. Yeah. And so we've proven that it is uniformly continuous. So sin x minus sin y is always less than or equal to x minus y times 1. So you're taking delta equal to epsilon? Bert, do you want some pain? I don't know. You can post the you can post the challenge or the question or whatever, but I don't know if I'm gonna want to do it. This person's probably just trying to avoid using derivatives. Okay. Hmm. I feel like I don't completely understand why sin of x is uniformly continuous, but it's probably not that important to me right now. Get... I guess that makes sense why you can just take delta equal to epsilon. Well, I almost feel like it would need to be like epsilon over 2 pi or something. No. Maybe you're okay, actually. Maybe I have it reversed. You could actually multiply the epsilon by something if you wanted. Yeah, I mean, we're just looking at this for fun. Corrupt converter. The question I was looking at already has an answer, but let's see what you're talking about. Oh, just for the render. So this power series, in terms of cosine, sine, cosh, and sinh. Change the infinity to render the graph. Oh yeah, I guess we can do that for fun. Guess we want a large value of a, don't we? Why? What? Why is it getting smaller? Floating point limitations? Oh, okay. Hey, the person just joined the Discord. I don't know if that's an I or an L. Island? If you're listening to the stream, welcome in. Somebody types them on Discord because I don't know if they're even listening to the stream. Hey, oh, is that you? We just hopped into the Discord? Oh, okay, okay. So I won't type back to you then. Thanks for coming over. Yeah, I've been doing that. I'm probably gonna go and do it again soon, or to be honest. But it was like a preliminary for studying like abstract algebra. So it's my first time really looking at number theory. Like I did a discrete math class years ago, but or I took a discrete math class, I should say, but I never studied number theory much. That's the first few terms of the expansion. See, I can see it's almost like a cosine with every other term removed. I guess you also have the 1 in front, which cosine wouldn't have? No, it would, because sine would start with it. Sine starts with x, so cosine starts with 1. Okay. So a sine version of this? Yeah, I mean, isn't this basically what I did the other day? Like, it's the same process. Like, it's a pain, but I feel like I could do it if I puzzled it out enough. Doing all the, like, the crazy, like, identities, I don't know if I feel like doing that. It's studying group theory currently bases similar prereq, although there are whole course on number theory go, of course, way more in depth. It's a very important example of finding the order, but an integer modulo n and other things. Oh, okay, so that's why it's used. So you might be interested. I'm sorry you just came in here. I'm already like advertising to you, but there's another streamer on Twitch named Pen Center who's doing actually an abstract algebra reading group, and it only just started like a week or two ago. So if you want people to talk to about it, I highly recommend checking out Pen Center's reading group streams. I think he's doing them once or twice a week. But if also in his Discord is where the discussion is happening. You might need to like ask him to be added to the reading group though. If you are interested, you absolutely do not have to do that if you don't want, but something that you might find helpful if you want other people to talk to about it. So I think that they're pretty close to getting into group theory. I think this will be the next thing that they talk about. So I'm trying to keep up, but I'm going to be super behind because I've never really studied algebra much before, so. Move that negative one to the end, it's easy. Yeah, but fixing the signs, like you don't have to do like I assume a like some kind of cosine plus cosh. You kind of feel like your midterms, you're gonna have to be very hard on yourself and study a lot. Oh, okay. Yeah, I mean, I guess good luck with the rest of the class. I'm not gonna be of much help with abstract algebra. Tencent might be able to help. I hesitate to call out other people exactly who are. Oh, okay. Algebra midterm is crazy. Yeah, no, it seems like a really difficult class. But I guess I'm gonna advertise one more thing to you and say that there's actually a whole community of streamers who do math on Twitch, and those are the ones I can recommend the highest. Penn Center's on that list. And then, yeah, so if you're interested in more like math streams on Twitch, there might be some of the others in that list who know, who might be comfortable like talking about abstract algebra if you did ever need help, although if you're just here for fun, that's absolutely cool too. But just want to, like, I like to make people aware that this resource even exists because it's a very small thing, so. And again, you know, no need to do anything at all if you don't want to. I just like to shout them out if I can. So, Wolfram Alpha knows the answer. Ooh, that'd be an interesting thing to try, right? That's the last of my advertising. Without someone asking, I guess. We have n equals 0. One to the n times x to the 4n, right? Over 4n factorial. Oh, wow. Look at that. Proof by Wolfram Alpha. It's maybe just not enough practice. I read a lot but didn't do enough problems. So when you're doing these, Amy panicked a lot, which caused me to be in time hurry. Gonna continue to work on something? All right. Well, thanks so much for the work. And I've had some classes where I mean, my discrete math class, I remember like I freaked out during a test. I think I managed to like calm down and do okay on it. But I can absolutely understand like being nervous for a class like that. Easy clap, yeah. Seems that you got so good, awesome. Absolutely. I was going to say trivial, Jed. And KMDR Cat, thanks for the follow. Welcome in. What's up? Oh, hey, 625 followers. What did I put my follower goal to? Did I start making them in 50s instead of 25s? I remember what I did. Oh, I made them in 50s now. Okay. I'm in the big leagues now. You're doing the same series, but with 4n plus 1? Let's try it. I'll just... Oh, yeah. I think is that the same one that you posted before that you had me? Or I mean that I found like the primitive version of this before you started playing identities, yeah. I think you posted that end result, yeah, in the Discord. The graph looked like, yeah, down here. Um, I think I'm gonna go into some abstract algebra stuff, or like, you know, keep on doing the preliminaries. So is there anything else you want to see from this corrupt? I mean, I could just link you the Wolfram Alpha page if you want to play around with it for yourself and not have to do the entry. Oh, you have to like manually copy paste that link because for some Wolfram Alpha links don't work well with Twitch. Could you have derived that? I actually could have gotten the I think I basically did get the other form before you started playing identities. Those identities involving cosine and cosh and all that together, I absolutely I do not know at all, and I would have got that on my own. But honestly, like cosine x, or what did I say? It was like sinh minus sine x over 2 or whatever. Like that didn't seem that bad at all to me. Maybe it was sine minus sinh, but whatever it was, like I don't know if it was like was there a reason to need to transform that? So I've fallen asleep listening to your voice already. I'll take it as a compliment, Nikas, but either way, welcome in. You also got a solution to the problem from earlier? The uniform continuity one? Or are you talking about like from the last mystery math, Yanis? Oh, was it that like number 5 problem that you kept working on and making a mistake on? Oh, for that one, towards the end. Really? Like, I really don't know how you approved that, so. Yeah, I kind of like this playlist. It's this one right here, actually. Tessarine's update. Pretty sure you got the recursive from the absolute value of Tessarine. Really? So, absolute value or magnitude? Square root. Absolute value of 8. Wow, that's so weird. Determinant of matrix form. Oh, I don't even know what that would look like. So, by some miracle, I actually did do some studying off stream last night. I was laying in bed. I got the file for this on my phone, And probably studying while in bed and about to fall asleep is kind of a bad idea, but I did read the actual text of, maybe I didn't absorb it, but I did go from equivalence relations all the way to the end of the reading. Past functions. Actually, functions is the end, isn't it? Yeah. So I read about equivalence relations and functions. Functions, I was mostly familiar with the ideas, although I'm not that comfortable with working with them in this sense. Equivalence relations were completely new for me. And we might try some of, like, I'm kind of sick of number theory, so I kind of want to try some of the exercises for, what have I not done? Complex numbers, induction, equivalence relations, and functions. Thinking about absolute value of a tessarine. 1 plus j is equal to 1 minus j. Really? Because j squared is positive 1. Why would that imply that? So you multiply them together and you get 0? So you'd have 1 minus j squared? Why does that mean their absolute value is 0, though? I guess one of them has to be 0 if they multiply to 0. I mean, is that necessarily true? You can have complex numbers multiply together to get 0, can't you? Maybe not. You can't divide back, really? That's super weird. They should learn about something like that in abstract algebra. Oh, okay. Oh, I'm kind of curious about modular arithmetic with powers. Isn't there some kind of special rule? Only way to get 0 is if one side is 0. I guess that's fair, yeah. If you multiply those two things, at least one of them should be 0. That's super weird to me, though. That means they both have to be 0, though? Like, why can't just one of them? It's only for positive integers. I think I actually learned this formula at one point. A and B non-zero. Huh. Okay, so yeah, that makes sense. Like, with complex numbers, there isn't a 0 divisor like that. Wait, so when you say... Yeah, I mean, I was just thinking about complex numbers as a way to try and, like, relate to something that I know. Z over 6z? What is z? This reads has planes of 0 divisors. I guess, like, 1 plus j and 1 minus j defines a plane? The book didn't use that notation, integers mod 6. Oh, that's what that means? Okay, so yeah, if you're talking about integers mod 6, I guess any multiple of 6 is going to turn out to be 0. Where a is a complex number? Oh. I was expecting a to be a real number, but okay. I guess that makes sense. I think the book for modulo congruence does the triple equal sign thing. Or, you know, the equal sign with 3 lines rather than 2 lines. Like right here in these examples are the only spot where I saw them talk about congruence. It's funky with higher dimensions though. 1, 2, 3, 4, 5, 6, 7, 8. This is 0 divisor? Oh. The reals are subset of C, yep. That makes sense. Zero, 1, 2, 3, 4, 5. So 6 doesn't really even exist, but 2 times 3 equals 0. Oh, okay, that's a bit. Also, z/6z means the integers mod 6. Okay. So I was thinking like z as like the common, like you commonly say like z is equal to a plus bi as a complex variable. So I was really confused when I first saw that. Okay, that's an interesting example though, Yanis. If you look at the dictation we use for group theory, and in particular the first problem, I guess, Lo, I hardly remember what a group is, to be honest. I know it's an uppercase Z, but I don't know. It's a shortcut, but if you don't want. Yeah, like if it's a, I guess if you're thinking about it as a function that maps integers to integers mod 6, then what I said is right, maybe? I feel like I'm not expressing in the right terms, but I had kind of the idea about multiples of 6, but I think I was proposing in the wrong way. Your 2 times 3 thing is better. Hey, underscore. Yeah, if you want to share Lo, please do. I can't promise I'll be able to do it because I haven't gotten to the part of knowing what a group is, but it's in Dutch. Okay. Round floors, ceiling, and mod function test screens. I don't know. I definitely don't know how those will work. I bet you I could figure out a lot of what this is saying. I'll say it'd be kind of fun. Let's look at it. Algebra 1, group theory. Hey, Valentine Le Bon random. First year course, right? Ooh, I don't think if you're talking about like I speak Dutch, yeah. Gropen theory. Perfect Dutch. So if you're, and this isn't really a first year course, I don't think, at least not in America. Maybe other countries do it different, but in the Netherlands? Oh, okay. If it's at least for an undergrad degree. Gropin theory. House in France. It is really? Okay, I mean, maybe Americans are stupid, but at least for... So I have a bachelor's in applied math, and like the typical things for like that first year students were doing like me is like calculus. If you're like pure math or you're really enthusiastic or you have more background, I bet you could do abstract algebra in your first year. There's like calculus and differential equations, stuff like that. Really? But I think we hit kind of fun challenge to try and understand this Dutch algebra. I feel like it's a terrible way to study, but it just sounds fun. He thinks this in America is more broad, in Europe it's immediately in depth. America's awesome graduate and PhDs though. Okay. So these in your bachelor's in engineering, don't miss them at all. Oh wow. Speak some German so you can read most of it. Okay. See, I should say the reason that I had this open at all is I'm not actually an active student. I got my bachelor's like 5 or 6 years ago now, probably closer to 6. This is part of a reading group that I've been doing just kind of for fun for abstract algebra. But anyone who is a student, it's actually possible to get credit. Actually, no, I'm sorry. That can be for... I'm getting mixed up. Penn Center is doing a complex variables course, and it will actually be possible for students to get credit from doing that complex variables course. It's going to be over the summer, starting in July. So, and how's up, Gabe? I give up already. The people at the bus stop today sounded very German. Yeah, I think I've seen people on the internet say that Dutch is like drunk German. Okay, we have a forward. These nuts is based on the syllabus. Okay. Okay, in this, I'm gonna guess that's textbook. But we handle... What the fuck is this word? Sorry. Well, what is this word? This shouldn't be allowed to be a word. Something about schnapps. I don't know. Division properties? Okay. Okay, it's one of those compound words. I guess that makes sense. So I know German has a lot of compound words, so probably Dutch also has them. You know, I'm understanding much less of this than I thought I would. I thought I'd be able to kind of figure things out a little bit, but aside from like these and A's and ofs, I'm not getting as much out of this as I thought I would. Let A and B be integers with B greater than 0. This is the division algorithm. Then there exists an integer Q. I'm completely guessing here. Integer, yeah. So I mean, this actual math looks very familiar. The actual words. Hey, induction, the induction step. What does that mean with Dutch Frage page un? What? I don't know what that is. I don't know. It's kind of fun to look at math in other languages and see if you can wait, 0 divides 0? That makes me uncomfortable. I guess it does. Because 0 is in the numerator. 0 over anything equal, or 0 times anything equals... Okay, oh god, that makes me... Okay, sure. Yeah. I guess that's fair enough. I just wanted to look at the first problem. You find it funny because the problems are quite difficult for a first problem, but it's basically simple number theory. Does make you uncomfy too? It's Euclid? Or... I don't know who that's supposed to be. Oh, okay, yeah, Euclid's algorithm. Where's the problems here? Did I already... Opgaven, I recognize that... Yeah, okay, yeah. I think the Danish word is very similar for like questions or problems or whatever. So this is the first question here. Let me break out my flawless Dutch. I'm already stuck. Induction, this guy has no chill on us. Okay. Let a and b be integers with a greater than or equal to 0 and b greater than or equal to 2. Show that for a t that is a non-negative integer, it's basically your index. Why do you use t as an index? Okay, I'm gonna let Google Translate do the heavy lifting here, I think. Hypotenuse toe? Oh, induction hypotenuse. I don't know what toe means though. Got some foot math going on here. Yeah, well, let's get into Spanish. It's perfect. Okay. The B number system. Oh, wait, is B raised to a power? Oh, this is defining a number system. Okay. The ABB integers with A greater than, yeah. Prove there is a T that is a non-negative integer and a series of constants from 0 to T, or, you know, index from 0 to T, that are between 0 and b minus 1. I guess, yeah, okay, that makes sense, because if you're in base 10, the highest single digit you can have is 9. Exists such that any number a is, you know, some combination of powers of b times your constant c. For in the case a equals 0, we can also achieve that c is greater than 0. C sub t is greater than 0. Oh, for a not equal to 0. Okay, that's an important distinction. That if a is not 0, c sub t is greater than 0. Is extra condition the numbers... I think we're saying both of these things are true. Now that a not equaling 0 implies that c sub t is greater than 0. But we have both these true at the same time. Which, I mean, it is implies? Okay. But you don't know... I guess you would define t to go as far as you need if a isn't 0. So I was thinking, like, if a is 1, couldn't your t still go out to, like, you know, 20 or, you know, some super high number? But you don't have to make it like that. Okay. And that with this extra condition, the numbers t, c sub 0, c sub 1, all the way up to c sub t can be determined unambiguously. So basically saying each number has a unique representation regardless of the base that you're working in. For any number that isn't 0, at least. Because 0's... I mean, isn't 1? Wait. Isn't 1 the same in any number system you want? Well, okay, no, it's fine if it's across. Well, within a number system, b minus 1 and b greater than 2. Okay, fair enough. Yeah, I mean, I guess, like, you know, for fixed to be each number. Okay, yeah, I think I was getting my rules mixed up. I was thinking like one is the same in every number system, but we're talking about a particular number system that you choose, I think. Right, a equals qb plus r as in point 1. Take c sub 0 equal to r. Apply the induction hypothesis for q. Ooh. It's quite a long exercise for the first one. You got the proof in LaTeX, but it's also in Dutch. Not sure if you did the induction part quite right, though. That's kind of an interesting problem. Oh. See, I mean, that makes sense. I've been thinking about things in terms of base 10, because that's what we're used to. Any number could be written as... Is that true? If you have like 22, you could write it as 2 times 20 plus 2. I think that's what this division is basically doing, and then you need to further break down that. Maybe like, you know, 200 is a better example. But you can further break down the QB inductively, one might say. I think it's, yeah, you get powers of B because in any number system where the system is greater than or equal to 2. Okay. Yeah, 2 is binary, and then I think I can see how you're getting your successive powers of B, because if you express Q using the same division algorithm, you're going to get another, like, you know, something times B plus C1 now, and then you'll get C1 times B from this original B right here. I imagine that's the idea. I guess I don't really know where the induction is going, though. Like, what are we trying... If you want to do it unambiguously... You didn't do it quite right. You did induction on the number. Yeah, because induction can prove that it's possible. It's not going to prove that it's unique, though. So that's where I was getting a little tripped up. Like, I don't know how you... I think the uniqueness... Yeah, okay, it's another proof. Okay. That's the problem. I don't know if I would want to go... Okay, first I have to prove the number is unique. Like, you assume it works for A. You would show it works for A plus 1. Uniqueness, you can use inequalities, really? Oh, A equals Q plus BR, that is a unique thing, isn't it? Okay. I know the inequalities work, but I believe you. See, I don't know if I would try this problem, but it is an interesting one. Oh, this is what you did. All right. Let's see. Oh, wow. 4 pages? Let's bring it up on stream. Just want to make sure. Okay, there's no like identifying information in this that I saw. Okay. So this is what Lo did for the problem. Okay, good. Small number less than a have unique base representation. Representation. I think I can see that. Yeah, I'm not sure. Can Google Translate work on a PDF like this? Like, I feel like doesn't the browser have some kind of automatic translator thing? Maybe that only works for web pages. Yeah, okay, the option is grayed out here. Base case. I'm gonna be honest, this might be a little bit too hard for me to understand. You didn't do induction on Q, so you're not so sure. Oh, this is the induction step right here. I already went too far down. So you didn't use the division at all. You did 2 cases. We're taking C sub 0 equal to B minus 1. Really? When we're all equal the max. Oh, for like a number like in base 10 to be like 9999999. Okay. I'm not sure, I guess, where the splitting up in cases comes from, but... Oh, because you're going to have the 1 get carried if you add 1 to it. And then for every other case, you're not going to have the 1 carry all the way over, so you won't get a new base. Okay. So cases for that seems reasonable. Oh, okay. So if you plug B minus 1 in for each of these constants, you're going to increase the power here by 1. So it'll be B to the T plus 1. Then you get a minus B to the T, and the one after it is going to be a plus B to the T. So you kind of get this cascading cancellation. Yeah, it's a little bit too long for me to be able to put in like Google Translate or something, unfortunately. I don't know if I understand where this factoring comes from, but I think you do get to the last step from this step. And this is the next case for when you don't have like the 99999 case. Since all c is equal to b minus 1, you add 1. You mean, I guess this is a true statement. I was doing the mental math differently. But this does work, I guess. But yeah, you do get this like, you know, plus bt minus bt thing, plus b cubed minus b cubed. So you can see how they all go away. I just would have, so I mentally removed all the c's before I ever got to this step here. Excuse me. Then what's happening here? The case where we don't have all 9s and we don't get a new power. Yeah, this one's a little bit harder. Oh, looks like you, just not equal to b minus 1. Okay, so this accounts for carrying the 1 until like a stopping point rather than getting a new power. So if you had like I guess 199 and you add 1 to it, you would stop at that final digit and not do a 2 power. Okay. And that one's okay. I guess that's fair enough. Wouldn't you still need like the plus? Actually, how? Oh, those all become 0, don't they? Because you carried the 1. Okay, fair enough. That's why there's nothing after this. Because these all become 0. Okay. And if you don't have any 9s anywhere, this still works. Because it just, C0 will get absorbed, or the 1 will get absorbed into C0. Yeah, okay, so I guess I see maybe your concern where you did construct the next number after A? I feel like this is okay. I mean, I guess you used the induction at the very beginning when you added 1 to each side. But it's probably not the intended solution like Yanis was saying. You like different solutions too? That's fair. Yeah. I don't necessarily see the flaw in this, although I'm definitely not the expert. That is kind of neat that you can do that. I think you can at least. But all those Ci are in the set from 0 to b minus 1. Really? Yeah, critical. This is Dutch. So I thought that was kind of a given that Ci plus 1 is between 0 and b minus 1. No, I don't speak Dutch. I like how Lowe's way of thinking reminds me of how I started to think abstract math with a lot of case splitting. I mean, just the two cases here isn't bad. I don't know what the rest of the proof is like. But I guess a more elegant proof does have less case splitting, but I mean, I think it's kind of a neat way to do it. Because I thought that Ci plus 1 being less than b plus 1 would be a given from how it was set up. Maybe not, though. B is the uniqueness part? Oh, okay. I mean, if you do it that division way, I bet it would probably follow a bit easier. But I mean, I don't know, that's like 3 paragraphs. I assume you take like a second number and assume that it's distinct and also works. And show that there's a contradiction. I guess I didn't even get through like the final part of your proof here, but or the final part of like the existence part. When you case split, you really get struck by more to the point proofs. Might as well that you tried to write it down in details. Yeah, I mean, I guess if you don't have the split indicates in the first place, that is like a, I think most people would think of it as a more beautiful proof. Not that it's wrong to split into cases. Thinking to the Dutch proofs, yeah, milk. It's the proof that Low 2001 wrote. It's basically like no matter what base number system you're working in, each number has a unique representation besides 0. And so it's basically like a math way of setting up that problem. And Lowe did a completely different way than was probably intended, but it's kind of a neat way. Yeah, if you do the induction on the number rather than Q, you probably do have to do that case splitting. I'm sorry I don't like that much to contribute to other than saying that it's kind of a neat proof, but I do think it's a neat proof for what it's worth. I'm glad you enjoy me trying to speak Dutch. You know, if I knew any stereotypes about Dutch people, I would have peppered some in, but like, I don't even know of a stereotype about Dutch people aside from that like drunk German thing, I guess. Yeah, I think I'm gonna go back to the world of English speaking number theory. Actually, maybe even I was gonna skip over the number theory because I'm kind of bored of it. I wasn't gonna do the powers of mod stuff. Yeah, thanks for sharing that, Lo. Okay, so what was up with the powers of mod stuff? Oh, because yeah, when you have two numbers multiplied with a mod, you can break it up into individual mods and then take the mod of that. Something like that. So because 5 mod 3 is 2, you do 2 to the 4th is 16, and then mod that with 3, and you get 1. Okay. And so if you had... What was like this? 7 to the 1000 mod 6, that seems a little harder, right? No, because 7 mod 6 is 1, 1 to the 1000 is still 1. And 1 mod 6 is 1? It's 1! Heck yeah. Okay. Then 6 to 1001 mod 7. Well, 6 mod 7 is 6. Wait. Well, now they're messing with me. Because I still get 6 to the 1001, don't I? Your first post-high school, your first post-high teacher used to say, if you have to describe a process via the use of a suspension mark, that's a hidden induction to be redacted, even if trivial. Like university? Or what's mean with... I also don't know what suspension mark is either. Like a ... An ellipse? Okay, so basically like if you have like, you know, something plus ... plus. Really? I guess it is, but like, how would you redact that? I feel like those are kind of necessary in like almost every type of math. It kind of looks like I made a face in chat. So how would you do 6 to the 1001 mod 7? Because 6 mod 7 is still 6. So it seems like the same trick doesn't apply. I mean, I guess it's true. Like it probably gets glossed over because it is like trivial, like underscores teacher said, but you can increase 6 by any multiple of 7, and there's a really simple one here. Subtracting 7? So it's -1 to the 1001? And -1 to the 1001 is an odd power, so it's just -1 mod 7. Which, don't tell me, is -1 mod 7. Six. So it's still just 6. Okay. Yeah, -1 mod 7. It is indeed 6 away from -7, I guess. Huh. Okay, that's a nice trick, Yanis. This thing is a very interesting question. Yeah, for sure. Hey, Bode. Doing NT, I see. Oh, yeah, number 3. That took me a second. Yeah, so don't become an NT master. I really don't want to be. Yeah, so I'm working through the preliminaries for Penn Center's abstract algebra reading group, and basically everything here is new for me except complex numbers and regular induction. So I'm kind of taking my time with it, and I'm sure I'm going to be super far behind. Oh, hey, speaking of Penn Center. Thank you so much, Penn. Well, welcome in, Raiders. Hey, Fenvox. Hope your stream was good, Penn Center. Hey, Diaz. Hold on, father. Okay, we were just looking at hey Scorpra. We're doing challenge math, which is doing math in Dutch. And we were looking at this proof that Lo in chat made. Oh, Lobster and Lo. Thank you both for the follows. Oh wait, no, this is the book. Wait, no, that's the book. Wait, am I crazy? No, okay, I am crazy, but it was basically like proving by induction that every number besides 0 has a unique representation in each base number system for an arbitrary base, I guess. It's kind of a neat problem. The raid alert, it's this Dark Souls like parody video, and this like clips kind of makes me laugh, where they're like just throwing lightning bolts. So in Dark Souls 2, lightning bolts were super overpowered too. Hey, Lila Degigi. Took a national test to become a teacher 1 week ago. There's an arithmetic question you can answer if you want. Yeah, sure, underscore. Hope that test went well. You can challenge with only 10 more integrals to go. Whoa, that's awesome, Ben. You'll finally be able to put those things away. Yeah, so we're just looking through this. This is a proof that Lo wrote for their class. So they're kind of asking me, or I mean, they're kind of asking in general if what they did is valid, which I can't find the hole in it, but that doesn't mean too much. Gonna be lurking? No worries, Pen. I appreciate it. And so Low, like, was looking at, like, you assume there's a representation just to prove that you can, or at least for the existence portion of the proof, you start with this for your induction hypothesis. You add 1 to each side, and then you have to construct a new number with that base. It's Dutch Bode. And then Low broke it into 2 cases. One, which is this first one, is if you have like if you're working in base 10, if you have 9999999 and you add 1 to it, you have to deal with carrying all those ones, and you end up with just you know, whatever your last base was to the next power up. Dutch is in a real language. Wake up. we were saying it's drunk German. Sorry, Low. It's a mix of German and English. Yeah. Hey, Frederick. Welcome in. So yeah, that was Low dealing with the case of all 9s if you're working in base 10, or, you know, all 2s if you're working in base 3, all 1s if you're working in base 2. And then for every other case, you have a bit more work to do when you don't have all the ones being carried. You have to worry about some ones carrying, but yeah. So we're kind of looking through this, and I basically had just switched back to looking at the abstract algebra book that's part of Penn's reading group. It's kind of fun to look at math in other languages and trying to figure out what things are saying. Take a Pythagorean triple PQR integers such that, right, p squared plus q squared is r squared. Show at least one of PQR are divisible by 5? Really? At least one of them are divisible by 5. Oh, I just saw what you said earlier though, about donating. You are absolutely not expected to, but I appreciate it if you do. But I mean, either way, like, thanks for, you know, sharing the interesting proof. It's fun to look at it. I just want a PQR divisible by 5. I never even knew that. I guess it makes sense, thinking of the Pythagorean triples that I'm aware of. Bode is saying mod 5 cases because a squared is congruent to 0, 1, 4 mod 5. It's an elo problem if you got on the test. Yeah, so every perfect square, that's 0, 1, or 4 mod 5? How would you know that? Ooh. Proof by trust me. Proof by intimidation. Just square 1 squared, 2 squared, 3 squared, 4 squared. Okay, fine. Yeah, that's fair. So yeah, 1 squared is 1 mod 5. 2 squared is 4 mod 5. 3 squared is 4 mod 5. No? Yes, 4 mod 5, because it's 4 over. I was going the wrong way. 5 squared is 0 mod 5. Because time was limited, the subject was long. After 30 seconds of thinking, that's fair. Um, so would you show that it can't be true? Like, would you say, like, maybe P is equal to, like, 5k plus 1? Show that's not possible to get something out of that? 5, and then 5k plus 2... Or no, not 5k plus 2 is pointless, I guess. So you would take at least one of them equal to 5k plus 1 and 5k plus 4 and show there's some kind of impossible thing there? I don't know how. What is like exams for this reason? For math, you really want time to think about it? Yeah, there's a real philosophical like question in there with how do you realistically test the knowledge of students? Especially when it's on such a big scale as like, you know, a country's education system. Yeah, I'm not sure how to progress with that Pythagorean triple one. It does seem like an interesting question, but everything I'm trying in my head, I don't really know like where it's going. But you're saying an easy number theory question, which I feel like we have different definitions of easy, but find all a, b, and c such that a squared plus b squared plus 1 is equal to c factorial. Hint, it's just mod. A squared plus b squared plus 1 is equal to c factorial. It's just mod. So you have to take the modulo of each side of something? So if you take each side mod c, it seems like the natural thing to me. Get a contradiction for c greater than or equal to 4 really easy. Do you do it mod C? I don't think modding A or B would be helpful. I don't know if there's like a constant number or like, you know, if there's an actual like modding 2 doesn't make sense to me, I don't think. Mod 4? Really? How do you know to mod 4? Without already knowing the answer. Mo, you're saying you have problems with time constraint, but then you feel like maybe it's my problem because I don't understand it well enough. What am I doing? Improving that way? Yeah. I think if you aren't as comfortable with module arithmetic, any module question is hard, so it's not great to say it's so easy to be discouraging. I mean, I'm just like mentally prepared for a question from Bode to be super hard. So if Bode is saying it's easy, I'm not gonna believe that for me at least. A squared is congruent to 0 or 1 mod 4. It's really common in number theory questions with squares mod 4, mod 8. Okay. So A is congruent to either 0 or 1 mod 4. That's fair if it's just experience, I mean. A squared is congruent to 0 or 1 mod 4. Every perfect square is 0 or 1 mod 4. Yeah, wait. Yeah, if it's a perfect square and it's even, it must be a multiple of 2. Or it must be like a power of 2. So that seems pretty easy from 0 for getting 0 when you mod 4. If you get 1 mod 4, like 3 squared is 9, which is 1 mod 4. 5 squared is 25, which is 1 mod 4. Okay, I mean, proof by plugging in 2 numbers, it checks out. Let me see if I can just like try and work through it. I mean, if you have a proof handy that you want to postpone, feel free, but no worries if it's like too much work. So I might kind of see the idea. I don't really know where to take it, but so if we take that and we do the mod 4 of each side, so if C is greater than or equal to 4, you're automatically equal to 0? Oh. Well, you don't know what a squared plus b squared... So, I mean, I assume we're going to get, like, this is some positive value, and can have a positive value be equal to 0. When you have addition with mods, you can distribute it like this? Then you need another mod 4 on the outside? IRL whiteboard? Yeah. There's that much to do mod 4 and you get a contradiction. I guess let me see if I get 2 stuck here. So a squared mod 4 and b squared mod 4 are either 0 or 1. Oh. And in either case, like, for any of the combinations, these are going to either add to 0, 1, or 2. That's always 1. And that means that's... Okay, wait. Let me... I think I see the idea now. That the result, like, this will be 0 or 1, that'll be 0 or 1. So our possible, like results for the addition are 0, 1, or 2. That's always equal to 1. So then this entire thing can be equal to 1 plus any of those 3 things. 1, 2, 3. You mod it with 4 again. And it's still 1, 2, or 3. And 1, 2, or 3 can be equal to 0. Okay. So you can only have a C between 1 and 3. Can we mod is it idempotent? I forget what that means. You would just like that algebra book teaches modular arithmetic, just makes it work more complicated than it is. Yeah, I never had a good understanding of modular arithmetic. I was never formally taught it, I don't think. Maybe my discrete math class kind of went into it, but not really. Like, I still don't really know what the tricks are, or like what the techniques. Like, that's not really the right word. Like, when you go about actually computing mods, I know fundamentally what to do, but then there's all those like weird situations where I don't know. Like when you have like something to a power mod something. Or I think that Diana said with like when we had 6 to the 1001 mod 7, I had no idea you could just like subtract 7 from 6 and get a much easier problem. But okay, I can see here how, like, you know, no matter what we get 1, 2, or 3 from the inside of the parentheses, 0, 1, 2, or 3 mod 4 are still 1, 2, or 3. None of those are equal to 0, so that can't be true for C greater than or equal to 4. If C is, I guess, 1, 2, or 3, what's possible? I need to look at the problem statement for what A, B, and C can be. Oh, okay. We don't actually. I'm taking them as. I know if we're allowing 0. I guess 0 we can allow. I don't know if this is the proper way to, like, note this, but so for A, B, and C, we could have 0, 0, 0, and this is true. We could have if C is now 1, we can have 0, 0, 1, right? And nothing else. If C is 2, we can have 1, 0, 2, or 0, 1, 2. If C is 3, they can both be 1. 1, 1, 3. I think those are possible answers. All right, so yeah, once it's all the problems where it's easy once you know the trick, but knowing the trick is the hard part. So I would never have thought to try to, like, restrict what C can be to make your case, or to make your guessing and checking way shorter. Now solve the problem, but instead of C factorial, do gamma of C. Oops, that's the wrong hotkey. Just to be a pain. But okay. Some modular arithmetic doesn't help for some whole. Sometimes modular arithmetic doesn't help for some whole integer equations. You have to move into different structures to exploit their properties. Yeah, I kind of taking the mod of each side. That's like a one-way implication, isn't it? Like you can't go backwards to whatever you modded before. And so I sometimes struck with the logic of that and making sure that the things I'm doing actually check out. Number theory, yeah. Got to do more to careful. Yeah, Lo, I agree. So I definitely don't mind, like, struggling with problems, because that's just part of learning math. Yeah, Fembox, I had the same thing. I managed to work it out in my head, but I did have to think about it. Moving to a structure you haven't defined yet? That's fair. I think the book maybe gives a bare enough, like, introduction to get you by, but I don't know. Forms are inequalities plus number theory in the same problem. Really, Bode? That sounds, to me, that sounds terrible. I'm glad that someone enjoys them, though. Which one of these looks fun? All right, this one we're seeing Pen Center do. Oh, I think this one is pretty quick, because this problem, it's like saying 2 to the n times 3 to the 2n divides 18. And then you just notice that 3 squared is 9, and that you can do 2 times 9 is 18 to the n. And of course, 18 to the n divides 18. All right, this one was interesting too. If that's for sure, because intuition, Euclidean division are enough. Okay. I remember seeing Pin Center solve this problem, but not understanding the logic in the slightest. I know it uses the idea that prime numbers are more, or it's basically the idea that prime numbers are more spaced out the higher you go. I don't remember how that one actually worked though. You know how to do 29? Okay. I mean, I remember Pin Center solution being like 201 factorial or something. E plus pi is irrational. 202 factorial plus 2? Oh, really? Okay. I mean, I don't know how you get that in the first place, but... Like, you started with like 200 factorial, I think, but there's some issue with that. And I don't really know what that would be. So I don't know how the heck you evaluate 200 factorial plus 1 being prime or not. It shows that 202 factorial has all factors from 2 to 202. Right. So 202 factorial plus 202 factorial plus 2, 202 factorial plus 3 should all have a common factor. Would they? I factorial plus 2 is equal to 5 times 4 times 3 times 2 times 1. Okay, I was getting... And so it'd be 2 times 5 times 4 times 3 times 1 plus 1. Okay, yeah. I see that Lila Diggy posted a question about 28. I was kind of going to move on from it, but we're looking at 29 right now, is what Penn Center is talking about. So, I mean, I guess let's try and understand this one. But I guess if 18 divides n, 17 divides n minus 1. "18 divides 36 and 17 divides 34. Yeah, I mean, I'm pretty sure this... I feel like my logic works, I'm just not saying it right. The idea is you do have, like, I guess powers of 18. You would set up this is equal to 17 times k. Isn't that simple as I was thinking? Oh, yeah, I was making it too simple. Okay, I guess we'll focus on 28 then, because I glazed over that. Is there mod property to show that 18 to the n mod 17 is equal to 1 to the n mod 17? I guess, yeah, because 18 to the n mod 17 is always just 1. And 1 to the n mod 17 is just 1? Expect every tiny theorem? (18 to the n minus 1 mod 17). Well, it's still 0 mod 17, which is... Wait. 18 to the n minus 1 mod 17, you end up with 1 minus 1 is 0 mod 17. And 0 mod 17... Is that just 17 still? So are you talking about Fermat's little theorem? I don't know why I'm praying right now, but by the way, it helps me think, I guess. Tiny person. I'm not good with modulars. I get 0 mod 7. How does that evaluate? It is just 0. Okay. See, that means it is divisible by 17. If you end up with 0. Okay. No tiny theorems required? Yeah, I feel like you wouldn't need that if the book didn't introduce it. But let me, It's the same idea. Okay. Fermat a Christmas theorem? I haven't heard of that one. Wait, but I'm not asking about Gerard, I'm asking about Fermat. Any odd prime p is expressible as the sum of two squares. If and only if p is congruent to 1 mod 4. The proposition has far fewer problems in it. I guess that kind of I guess it's easier to add on problems as you make more additions. Chicken McNugget theorem? Oh, this is the same trick that Bode was saying, where a square mod 4 is 0 or 1. Is that what you do for the underscores problem then with Pythagorean triples? Would you mod 4 that and then you get something that you can work with? Oh no, it's divisible by 5. Never mind. That's a bit of a different problem. If I have the unobserved cases, okay. Like in your problem, okay. What's the chicken McNugget theorem? Cantor's Paradise. Those don't look like McNuggets. Those are like some generic. Oh, create it. Oh, no. I'm not creating an account. Yeah, the hairy ball theorem I've heard of. Cox-Zucker machine? I'm Googling that. I'm not Googling it on stream, but I'm Googling it. Cox-Zucker machine. Okay. Here's a Wikipedia article, but... Oh god, please no torsions. Yeah, I don't know what any of this means, but I'm glad I know it exists. As someone who has searched relentlessly for a Cox-Zucker machine online, I have finally found one now. You have to go get... Sorry. Enjoy your grocery shopping, Penn Center. Thanks so much again for the raid. Where's their Cox ring? Cocksucker machine. To your Fermat's Christmas list? If one of the Cox-Zucker machine is related to the hairy ball theorem, name origin section stating the obvious. First year graduate students at Princeton? Okay. For the express purpose of enabling this joke? Oh yeah, the Cox ring! Oh my god. Teacher's surname is Cox. Oh my god. I thought the dirty names in math ended at hairy ball theorem, but I was very wrong. Tits alternative theorem? That's another one I'm going to take the browser down before I Google it. Tits alternative theorem. Jacques Tits? No. Okay. That's really just me giggling at dirty names now. Jacques Sacre Bleu. The tits group. Cocksucker machine for Fermat's little size theorems. Oh my god. This is ridiculous. Is it learning math fun? Dinosaur. It's been so long since I've seen your name. It's good to see you again. Yeah, you got here at the perfect time. We're talking about tits and Cox-Zucker machines and Cox rings. Oh my gosh. Jacques Tits. Oh my god. Oof. Sorry, I'm getting all bothered here. I should have done that in the mic. I'm sorry if that made a terrible noise. Slutsky's theorem? Okay, let's be the last one, then I'll go back to actually looking at math, but... Slutsky is a pretty like awesome name. I hope that that's real. It's real. Slutsky. Oh, Slutsky's theorem is also attributed to Harold Kramer. Slutsky's theorem gets around, I guess. Okay. Oh my gosh. Yeah, and the chicken McNugget theorem. Yeah, I was wondering like how to pronounce that because it looked like Eugene, but there's no extra e at the end. Yeah, Harry Ball theorem. I've looked up before. I've looked at Harry Ball theorem before. Let me tell you. God, my throat hurts from laughing. Let me drink some water. You actually used Slutskis this year in some written variables course this year? Oh, nice. It's probably like Slutski or something too. It's probably not even pronounced like that. I mean, or maybe it is, but. All right. So I think I kind of verbally got to the bottom of 28. Integration by parts. Welcome in. You're kind of straight. Yeah, I mean, I hope you were here for when we're looking at things like, you know, Tit's alternative theorem and Slutsky's theorem in the Cox-Zucker machine. It's definitely my expertise in math. Let me scroll up and see what Penson was saying about 29 here. Actually, oh, and see Bode is saying, for 29 you could choose n such that n equals p minus 1 factorial for a relation of p. It really isn't anything specific. Yeah, I don't see what Penson was saying with having multiple common factors when you have more than two things to work with. So you're playing cycling through two songs? No, it's just kind of generic sounding music, I think. It's just a random YouTube playlist I pulled up like 2 seconds before. Harry Ball theorem say? I don't really remember. It's safe to Google it if you want to though. You don't see anything weird. P divides 1 plus p minus 1 factorial. Favorite music artist? It's a Ukrainian metal band called Ginger. They're my favorite band. An excerpt from Cox's speech at Zucker's memorial a few weeks after we met, we realized that we had to write joint paper because the combination of our last names in the usual alphabetical order is remarkably obscene. You like Ginger underscore? Hell yeah. Yeah, they're so awesome. They go from 34 to 35. What's 34 and 35? 35 is easy with modular. The nth Fibonacci number is less than 2 to the n. Basically, it doesn't grow exponentially. Really? Or it grows slower than 2 to the n anyway. I thought the Fibonacci sequence was super fast. Maybe not. Prove by induction on n that for all positive integers n cubed, or for n, that n cubed plus n plus 1 cubed plus n plus 2 cubed is a multiple of 9. I've done a very similar problem to this. With modular arithmetic. So I assume it's gonna be a trick. It's gonna basically be what Bode was saying before with every cube is gonna only have a couple of cases mod 9. Yeah, you know, let's explore this one. It's gotten my interest here. See if I can work this one out. Okay. So, and it's a positive integer. I want to show that n cubed plus n plus 1 cubed plus n plus 2 cubed equal to 9k, I guess, for some integer k. So yeah, I guess we're gonna mod 9. I guess I mean, I'll even like write out and do a little chart here. So if you have n cubed mod 9, just work through the first couple of cubes. One mod 9 is 1. 2 cubed is 8. 8 mod 9 is 8. 3 cubed is 27. 27 mod 9. Oh, no, it's gonna be 0, isn't it? 4 cubed is 64. 64 mod 9. Is that 1? Oh, is it gonna be 1 and 8? It's kind of convenient if it is. Or 0. 125. Okay, 9 goes into 90, 99, 108, 117. And that's where we stop. So we get 8. Ah, okay. 0, 1, or 8. I mean, that's my crappy proof by induction, and I'm sticking to it. So if we take the mod 9 of each side, it'll be n cubed mod 9 plus n plus 2 cubed mod 9 plus, oops, n plus 1 cubed, n plus 2 cubed mod 9. mod 9 is equal to 9k mod 9 is 0. Right? I see your trick that you're saying, oh wait, hey Amorphous on YouTube, can you quickly demonstrate what it means for graph to bounce or cross axis depending on even/odd multiplicity? Amorphous, are you still here? Because I'm sorry, because I missed your chat. I believe the rules, yeah, if it's an odd multiplicity, it crosses. If it's an even multiplicity, it bounces. I can show you like what that means. But let me know if you're still here, because I'm sorry if you already left. And then I'll look more at your trick in a second, Bode. Okay, so what we do here is each of these numbers are 0, 1, or 8. Do we, I guess, do we have 9 cases to work through then? Or there's even 27 cases. How many ways can you, if you have 3 things, how many ways can you arrange 3 of them? Is it 6? It's because it's 3 factorial? Maybe it's not that bad to just work through all the cases. If they're all 0, you get 0 mod 9. Wait, what's the question? Just to prove that this is true, right? Oh, you are here, Amorphous? N plus 1 is dependent on n? I thought that as long as it's a cube, you're fine with the rule that I said. Oh, you can reduce your cases if you know that. Oh, because it's going to cycle with 180, 180, 180. So you only have, okay. Well, it's going to be 180 or some other like permutation of that. So I can save you some work is what you're saying, Bode. So it's going to be 1 plus 8 plus 0 in some combination. So you get 9 mod 9 is equal to 0, which is a true statement. Okay. And Amorphous. Did you have to use induction on this? I mean, you technically, I guess, probably should do induction, but unless you're doing what Bode says, which I haven't looked at yet. Okay, so Amorphous, you're asking about the multiplicity of a root and whether it crosses or bounces off the x-axis. Demonstrate what it means. Okay, so a bounce is basically it just touches the x-axis and comes back up, either going up or down, and then crossing the x-axis, it just crosses the x-axis. And I'll give some more examples. So a way that you can remember this is with like just take simple polynomials like a parabola y equals x squared. Like if you're doing a problem like this, you hopefully just know what x squared looks like, which is a parabola with the vertex at 0, 0. That's a bounce because the root is 0 with multiplicity 2. Whereas if you have a parabola like y equals x minus 1 times x minus 2, now you have 2 separate roots here at positive 1 and positive 2. So you're kind of forced when you draw your parabola to cross over those. I would say that's kind of the quick way of trying to remember kind of when you cross and when you bounce. It's even true for a line too. If you have the line y equals x, the root of it, 0, only occurs once. Same with x cubed. Now, I guess with cubes, you can have a bit more fun, or with cubic functions, you could say, you'd have a cubic function like x minus 1 squared times x minus 2. This is also cubic, but it looks a lot different from that one above. in this case, we still have roots at 1 and 2. But you have to remember how a cubic function normally behaves. If your leading coefficient is positive, like we have in these two cases, you come up from the left and you go up to the right. So we know we're coming up from the left, and we have to bounce at x equals 1, because it's x minus 1 squared. So the squared means we bounce. So we come up from the left, bounce, come back down, and then at some point we have to cross through 2. So that's kind of like the quick and dirty way of like drawing that graph. Does anyone know if that makes sense, Amorphous, or if there's something example in particular you want to see? We are free people to do what we want. Yeah. It doesn't equal it's congruent. Ooh, that's a good point, Bode. Yeah. Or yeah, that's something about. That's a very fair point, Bode. Should I have been congruent as soon as I took the mod of each side? And please do. I don't mind you correcting me on this stuff because I'm very new to it, so I don't know what's right or wrong. It's like, would I write it like that? The next explanation. Awesome, I'm glad I was able to help you. Let me know if you run into anything else. I do these streams on Tuesdays, Thursdays, and Saturdays. But hey, thank you for the question. And sorry, my explanation was kind of like split between the two different problems, but glad I was able to help you. Yeah, you agree with that, Bode? Okay, cool. Oh, I forgot the problem cut off my last cube example a little bit, but the idea is still there, so. Okay, so let me look more at what you just said, Bode, with or not what you just said, but what you said before with the trick for knowing how it cycles. It's kind of advanced, but if you want to calculate fast, you can use the fact that 5 is congruent to -3 mod 8, or 6 is congruent to -2 mod 8. Why would that be helpful? I'm trying to figure it out. I need to get more emotes uploaded on Oh wait, in the little preview thing up there it works. For whatever reason, in my view, it doesn't work. I wonder if it's just my OBS being weird. It's kind of fancy. If you want to calculate faster, you can use the fact that 5 is congruent to -3 mod 8. Or 6 is congruent to -2 mod 8. Yeah, I don't see how that trick is used. So I think you said that comment at the time that I was figuring out what the cycle of mod 9 is for cubes. And I don't see why modding 8 is helpful. But if you're not available to explain, it's all good. Not like you're obligated to be here. Instead of calculating 8 cubed. Oh, oh, to save time for doing the actual calculations. Okay. I see. So yeah, I would still have to do the same process I did with the table, or, you know, either mentally or actually writing out the table, but I could have made the calculation a bit simpler. Instead of figuring out what that 5 cubed is 125, I could have, Are we modding 9 though? -4 cubed. This is going to go to -1 times 1. Okay. Yeah, because we already know what 4 cubed mod 9 is. So all you have is the -1 thrown in there. Okay. I thought it was a trick. I thought you were saying that that would be some kind of trick to get around doing the table in the first place. It seems like you still have to do that to get a sense of what your cycles are. What is this one? And the cut as from Songs in the Key of Life. Stevie Wonder mentions the equation that 8 times 8 times 8 is equal to 4. Find all integers n for which this statement is true, mod n. Where n cubed is equal to n. Wait, oh, mod n. Wait. Is it n cubed mod n is equal to 4? Is that what they're saying? No, but that's 8 cubed. I don't get how they're saying you should translate this. Get to do or just members like you? Okay, that's fair. Hey, Kaden. No, I'm not helping out anyone else right now. I don't remember your problems as being that easy, but I can take a look. 8 cubed is congruent to 4 mod n. Okay. The whole congruent notation I'm not very used to. It's basically saying that 8 cubed and any multiple of 8 cubed will give a remainder of 4 if you mod it with n. Questions really we've been paying attention to class, so it's hard for you, I guess. Okay, Kaden. Let me know. I guess either type it out there in chat or post it in the Discord if you're still in there. Oh, okay, cool. Let's see what this is. Bo, you said yeah. Thank you for letting me know. I mean, just in the future, when you do, it's not really a big deal. Like, I'm not too picky about it, but if you do post questions, do it either over in math discussion or math homework help. It's not really a big deal if you don't, but just to keep things a bit like better organized. For this one, you're all good. ABCD is a rectangle with A on the line y equals x plus 10, B on the line y equals minus 2x plus 10, and C and D on the x-axis. If AD is 4, what is the area of rectangle ABCD? Ooh. So yeah, since AD is 4, we know the y-coordinate on the line here. Huh. How do we figure out? Oh, and once we know the oh, I see. Okay. Oh, do you know? Oh, it's the wrong one. Oh, okay. I got excited because I figured out how to do this one. It's all good though. Let's see. Oh gosh, this is a 2-pager. Already posted it twice. Okay. So maybe easier. Let's see. Triangle ABC has vertices 0, 0, 9, 0, and 0, 6. Okay, they have nice coordinates for a triangle at least. The points P and Q lie on side AB such that AP equals PQ equals QB. Okay, so it trisects it, I guess you could say. Similarly, the points R and S lie on the side of AC so that it also trisects it, if that's even a word. The vertex C is joined to each of the points P and Q. You're asking about part C? I'm probably gonna need to work through A and B to understand what C is asking, though. Pentaginator is a weird word. Is that somewhere in the question, or did you like see that somewhere else? Pentagonator? I don't know what part of that word to emphasize, I guess. Determine the equation lines. Terminator went math, yeah. Determine the equation lines through the points P and C. I think I can picture what's happening here. If pentaginator, that's how I want to pronounce it, is a word. No other word can surprise you. That's a good point, Yanis. You have a general question way after Caden? Okay, amorphous. Sounds good. The line segments PC and RBs intersect at X. The line segments QC and SB intersect at Y. Oh God. I need to draw this. My mental picture of this problem is quickly getting blurry. I guess it'll kind of fit on the left side. Whiteboard time. That's how you know things are getting serious. Okay. So let me draw the triangle here. ABC has vertices 0, 0, B is 9, 0? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. C. And so we connect ABC as a triangle. And then on side AB, we have points P and Q that split this into 3s. So I guess we have P there and Q there. And then, so we're gonna have, I think, R and S here. Which one is R, which one is S? A, R, 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 R. Okay. 3/8, yeah. The vertex C is joined to P and Q. So we draw that line and that line. I probably should have done this in a different color. Then we'll do the same for B and R and S, I think. Yeah. Tell you what, this line right here is some BS. Okay. It's a whole mess now, but you're probably it's 4/8. Huh. Okay, so the equations of the lines are pretty quick for me to get if I need them. Let's see what part C says. So the line segments PC and RB intersect at X. We're talking about PC and RB intersect at X. Okay. The line segments QC and SB intersect at Y. QC and SB. Y. Prove the points A, X, and Y lie on the same straight line. Interesting. Okay, so to me, maybe there's some elegant way to go about this, but, well, kind of the caveman way to do this is to figure out the actual points for X and Y. And we might just do that anyway. Just visually, I mean, so getting X to be 2, 2, and Y to maybe be like 4, 4, or 3, 3, which means we can definitely draw the Y and Y equals X through it. Oy, okay, so what lines do they get you? Oh, they want you to get the equations for all 4 lines. Is there an easier way, Jed? Like, I'm trying to think of a clever way to simplify it, but parts A and B are to get the equations for all 4 of these lines. So I assume they want you to use those lines to figure out the intersection points. So I think we do need to go back and like do parts A and B for ourselves to know the equations of the lines. Well, yeah, I did determine the points of R and S in P and Q. I guess I didn't really say it, but like P is definitely at 3 and Q is at 6, and then R is at 2, S is at 4. So you know 2 points, you can calculate the slope. Yeah. Yeah, Jed, that's what I'm doing. So for the line PC, there's going to be a whole lot of arithmetic here that I think I'm going to do in my head to save some time on the problem. You're only asked about part C, so I'll kind of try to quickly get the equations for the lines for myself here, since I like you know how to do that. So for PC, the y-intercept is 6. The slope of that line, it's going to be a negative number. We rise -6 and run +3, so -2. All right, so PQ, we have the same y-intercept, except this time we rise -6 and we run 6, that's -x. BS, which I love to write, is going to, that y-intercept is now 4. We rise -4, we run 9. -4 over 9x. BR. Now our y-intercept is +2. and then we rise -2, run 9. So those are 4 equations for the lines. I hope this matches what you got, Caden. Oh, no worries, Jed. And so now the point X is the intersection of, we said, PC and BR? I did something wrong? I'll look in a second. All right. PQ or QC? PQ. Oh. You make a strong point. QC. Or CQ. I don't know why I reversed the alphabetical order, but let's keep on reversing the alphabetical order. Okay. Fair point, Jed. Okay, so X, I got this notation right though. Yeah, PC. So let's figure out where X is. So we have the equation of 2 lines, and it's boiled down to the problem where we want to find out where they intersect. So let's set them equal to each other. Minus 2x plus 6 is equal to minus 2. That's not a 2. Minus 2 9x plus 2. Solve this equation for x. Man, they're making me do fraction math. That's not cool. It's going to be 18 over 9. Well, which one do I want to bring over? If I want to avoid a negative number, I'll add that over here. So we get 4 equals 18 over 9 minus 2 over 9 is 16 over 9. X. Multiply by 9 over 16, and you get 9 over 4? I hope I'm not tripping up on the arithmetic here, Caden. I can show my work more if you need it, but I'm hoping that like this little stuff that you're familiar enough with. So importantly, this is the x-coordinate of their intersection. We haven't figured out the y-coordinate yet. We can plug it into either of these 2 original lines to figure out what the y-coordinate is. It should be the same if you did the math right. I hope I did the math right. Just plug it into... This one looks a little bit nicer because the 9 is going to cancel with the 9. Minus 2 over 9 times 9 over 4 plus 2. The 9's cancel, you get negative a half plus 2. Minus 5 over 4? That's not good. Oh, no, you can still... No, you can still make a line between those points, I think. Yeah, it's a whole bunch of calculations, unfortunately. Equation for PQ is y equals 0, 0? Oh, okay, yeah. I see what you're talking about now. I was expecting these 2 to be equal to each other, and they're not, and that disturbs me. Is that a... That's not negative 5 over 4, by the way. They're still not equal to each other. Negative a half plus 2 is 3 over 2. They're still not equal to each other. That might be okay. We're probably okay. It's gonna be... I think we'll be okay. Let's do the same thing for y and pray it works out. So y we said is QC in BS. It's a whole lot of BS. Hey, foreign CSGO. Like number or graph theory. I can't say I particularly like either of those. You might have some other look with some of the other math streamers, like, I'll just do a general shout out to all the math streamers. I'm not particularly good with either of those 2 things, but most of the other streamers on that list would be good to talk to if you want to talk more in depth. Like, I'd say Zach, Penn Center, Ian Stuckey, and maybe Obi off that list. might be a bit more familiar. I'm not sure what all they're familiar with exactly for number and graph theory though. All right, so Kaden, I'm gonna go and get it's kind of confusing because I'm using capital Y here, but I'm gonna get like that intersection point up there. The same way, we have QC and BS, so let's let them equal each other. Minus x plus 6 equals minus 4 over 9x plus 4. It's a 4, not a 9, I promise. Solve this for x. We're going to add x to each side, subtract the 4 over. We get 2 equals 5 over 9x. So x equals 18 over 5. Ugly number, but hopefully it gives us something. Figure out what the y coordinate is. Plug it into that line. It doesn't really give us an nice of a cancellation though. Minus 8 over 5 plus 4. Get a common denominator, that's 20 over 5. Minus 8 is minus 12 over 5. No, positive 12 over 5. I keep flipping the sign for some reason. Just gonna go toss some number problems. Oh, okay. Yeah, for Francisco. If it's like just for fun problem, then I don't always do those. Or I mean, Fembox might want to discuss if you want to put some problems in chat anyway. My emphasis for my stream is more like the homework help stuff. I have been doing some kind of more for fun questions recently, but if there's a homework question, I'll usually always prioritize that. Like the one I'm doing right now from Caden. And I think we have another one on deck from Amorphous. Okay, so my plan here is to... We have the x and y coordinates of x and y, confusingly. I'm going to make... we now have 2 points. We can make the line between them, and I'm going to pray that 0, 0 is included in that for A. So blindly just ignoring A for now, we'll just only make... the line between these 2 points. I'm going to do it, I guess, up there. You can do it in red. I'm going to do it up here. So we can get the slope by doing... let me actually write down the coordinates. 9 over 4, 3 over 2. Y is 18 over 5, comma 12 over 5. All right, so to get the slope between these 2 points, we do y1, or it doesn't really matter which one goes first, but I'm going to do that y minus that y for no particular reason, just choosing one arbitrarily. That x minus that x, you have to do it in the same order. Really annoying fraction math. Let's see. 24 over 10 minus 36 over 10 is minus 12 over 10. 36 over 20 minus 45 over 20 is minus 9 over 20. Unflip the fractions. The negative signs cancel. You get 12 over, this is over 20. I messed up the ordering a little bit, but you end up with 4 over 3 times 2, which is 8 over 3. That's our slope. Hey, Pen. We'll make this question as boring as possible. Yeah. You don't agree with Euclid that 2 points only have one line? Yeah. 2 2/3? Yeah, it's not the same as 2 2/3. Okay. So we know that y equals 8/3 x plus b, and let's pray to God that b is 0, so it includes point A. We figure out what b is by plugging in either one of these points. Does one of them look nicer? they're both basically the same. I'll take x because the fractions are slightly smaller. 3 over 2 equals 8 over 3 times 9 over 4 plus b. 3 over 2 equals 2 times 3 is 6, last I checked. Oh no! I did something wrong. We should get 0. Do it all over again? Wolfram Alpha is going to do it all over again. Why not just use Anna's archives for the peeps on Twitch? What is Anna's archives? Never heard of it. Amorphs on YouTube said, why not use Anna's archives for the peeps on Twitch? Anna's archives? I have no idea what that is. Just found a gem? Oh, you're suggesting for the people who are looking for books. Anus archives? What if I am, Casey? It's like Z library. Oh, okay. No, the person was saying, Anna's archives. You do. I appreciate you, being understanding of my lifestyle choices. Sounds fun. I would expect you to say that, Anders, but I agree. It sounds fun. Minus 2 over 9x. Maybe someone has gone out there and archived anuses throughout history. X is 9 over 4. Okay. Now, if we plug a 9 over 4 into that line, let's say, we get 3 over 2. Okay. My Wolfram Alpha seems to, as long as I did the equation for the lines right, Wolfram Alpha agrees with my coordinates for x. Let's check the ones for y. Minus x plus 6 equals minus 4 over 9. X plus 4. Yeah, sure, amorphous. This one, it is taking me a bit of time, so 18 over 5, that's what I got to. The elements, oh, pen. Getting in there. 12 over 5. 12 over 5. Speaking of which, the YouTube peeps, the Elements channel has a bunch of math-related videos on it, if you want to check it out. Does Wolfram Alpha know what to do line connecting 9 over 4, 3 over 2, and 18 over 5, comma, 12 over 5? Is that something Wolfram Alpha knows how to do? I did something wrong. I'm humbled by this kindness. Did I set up the equations for the lines wrong? Let me look back at the... A blueberry scone and you're very happy? Oh, that sounds amazing right now. A blueberry scone always sounds amazing. Let's look at my equations for the line. Oh, what? Oh my god, all right. Let's re-examine my equations for the lines. Amorphous. I'll happily get to your question once you type it out. All right, so we said PC. The x-intercept is definitely 6. We rise -6, we run 3. So I think -2 for the slope is reasonable. For QC, y-intercept is still 6, and this time we're running 6, so that -x seems reasonable again. Maybe it's these. They were giving me weirder numbers. So for BS, we're saying the y-intercept is 4, which seems reasonable. We rise -4 and we run 9. Yeah, what's the problem here? Did I copy one of the equations down wrong over here? Like, BS. I don't see what I did wrong. Yeah, I mean, Penson is a better person to like answer that, but my understanding is that Penson is basically doing streams once every 2 weeks or twice a week or at some kind of regular interval, going through the questions, or like he says, you know, by this date, let's read through this chapter, and on stream, I'll go through these questions with you all. That's kind of like how it's structured, I guess. There's other reading groups out there that are structured like differently, but that's more or less how it's been working as far as I've seen. And Penn Center, if I'm mistaken, please speak up. But better think of x as 9/4 or 6/4 to better see the ratio. One chapter-ish every 2 weeks. Okay. Yes, like I'm doing it, but I'm just accepting the fact that I'm going to be super behind in that group because it's all a lot new. It's all almost entirely new for me compared to a lot of the other people in the group. AX and Y are collinear femblocks? In the 3:2 ratio, the denominator for Y is 5. Oh wait, but the ratio is so... (3y = 2x). Why don't my numbers agree with that though? Did I do my fraction math wrong? But like when I plug... Wait. Oh, the scale of Wolfram Alpha. I did do my fraction math wrong somewhere on the board. Okay. No, I got fooled by Wolfram Alpha's scaling. Okay, thank you, Fembox. I definitely... I should be getting 0 for B here. So I found the slope is 8/3. Actually, that has to be wrong. I did miss my... And Amorphs, I'll get to that in a second. I think I'm almost at the bottom of this problem now. I think I messed up. I must have messed up on the slope calculation. It should be 2/3, right? Or 3/2, or whatever we said. I already forget, but we do it the long and painful way. 24/10 minus... Oh, that's what I messed up. I didn't do that as 15, I don't think. Did I? I don't remember what I did anymore. 18 times... What did I say? 18 times 4? What did I do? What mental math was I doing? I think I just did some crazy mental math. What is 18 times 4? 72? Yeah, I was just on one when I was... I think I said that was 36. Oh my god. Do not trust me to do mental math, people. That top one, 9/10, right? You do that much mental math? That bottom one is 27? I think so. 9/10 times 20/27. 1/3 to 2/3. Okay. And that agrees with what Fenbox said. Fenbox, you are a hero. Okay, so, Caden, if you are still here, now I finally figured out how to, add and subtract fractions. At this point, we know the equation of the line is y equals 2/3x plus b. To be completely sure that we're right, we need to verify that b is 0, because that means it'll pass through the point 0, 0, which is a. So let's plug in either of these 2 points and hope that b equals 0. So I'll plug in that one, x, so 2/3 times 9/4 plus b. How does that math? 3/2 is 3/2, so that's b. So b equals 0, so y equals 2/3 x, which certainly passes through 0, 0. Okay. And what was the actual question? I forgot to take my camera down. Sorry about that. Like the webcam. Prove that AXY lie on the same line. So I'd say that we've proven it by finding that line. So Caden, let me know if you have any questions. Let me read through what Amorphous has been putting in the YouTube chat here. So Amorphous says, okay, so I'm basically registered to take Calc AP exam in a month, and I decided to self-study and procrastinated it so hard. Okay. What prereq skills do you say you need to know cold for Calc? What you say is heavily used in Calc for evaluating limits, derivatives, integrals, etc. I'm pretty good at factoring. You have unit circle memorized. Perfect. You go to the trig of functions. That'll give you a huge step up, being comfortable with those things. Thing is that since you never took Calc, we don't know... Are you taking the AB exam without taking the class? Recommend someone like me to know, having already taken Calc specifically for Calc AB. Oh, so you've taken Calc separately, and now you're doing the AB exam. Okay. Vaguely familiar with the concept of limits, partially derivatives and integrals. You'd rank it limits, derivatives, integrals in terms of how familiar you are with them. Okay. Let me remember. So I think the Calculus AP exam goes to basic integration and does not do more sophisticated techniques. Let me... Okay. So yeah, integrals, but not like integration by parts or anything that thing. So I assume you're only doing like U subs with integrals. And I love recommending the site to people, and I think it's the perfect site for people in your situation. Oh, since I already took Calc. Have you not done Calc before and you're just taking the AP exam? That's pretty brave. But yeah, it's something you said that you're comfortable with factoring things, which is a huge help. It's also with trig and that stuff. This is my favorite site for everything with calculus. I linked you to the Calc 1 section, which will cover more or less everything in the Calculus AB exam. Like you probably don't need to worry. There's some things that you could like. Yeah, honestly, I think this is basically exactly going to cover the stuff you'd see in Calc AB. I'd recommend going through this site if you want hard things that you can actually like study. So it'll cover your limits, your derivatives, and your integrals up to U substitution, which is probably what the AB AP exam will cover up to. But yeah, I think you already know the broad topics to study, which are limits, derivatives, and integrals. I haven't used Khan Academy much. I've seen a lot of their content is in video form, which I'd rather just have it written out, so I don't tend to use them that much. So I have a hard time rating Khan Academy. AB, yeah, I don't think it stands for anything. There's A, B, and BC. Yeah, exactly as Fenbox says. AB goes with like differential calculus, and it goes just barely into integrals with U subs. BC is like the second semester of calculus. Well, it's really the first and the second semester of calculus. It's taken by high school students. So AB, you get the entire high school year to do like differential calculus, like the first semester. And BC, you do AB all over again, plus the second semester of calculus. Exactly, yeah. What Fenbox is saying. So Khan Academy, I've heard good things about them, but I haven't used them for myself, so I can't give you that like personalized thing. I do really like this site because it gives you like a very direct and to the point explanation of things that's focused on helping you get through your class rather than like, you know, waxing on about the theory, which depending on what you want to do is kind of a downfall of it. But if you're trying to get through the AP exam, I think this is a really helpful tool. If your goal is to really learn the theory of calculus, I wouldn't go to the site, but for just trying to get through your class, it's amazing. I'm trying to think of things that I can call out to you in particular. Just recommend me. Yeah, so people recommend to me with like all these questions that, from Calc 1, I'd be able to handle. Then Loxane is saying, I like Khan Academy. I've heard a lot of very good things about Paul's notes too. Okay. And if you are willing to make the switch or like the hop over to Twitch, there are many more math streamers on Twitch than just me. Penn Center or, you know, the Elements on YouTube has the channel or videos posted. I'm not sure if they're on calculus though, but most of the math people who I'm aware of are on Twitch. I'm not aware of a math stream on YouTube, to be honest. I should probably look. Oh yeah, I've heard about Brilliant as well. I think some of it you have to pay for, but there are some free things on there. And yeah, someone says it's a ton of practice, which this site provides you. So if we even look at, you know, just derivatives of trig functions, that like these example problems, they're very well chosen to show you potential tricks that questions will pull on you. And if you want even more, there's practice problems and assignment problems at the top of each page. So I'd highly recommend like reading through its explanations and understanding it. Um, Shinkaden, I haven't seen you say anything in a while. Are you still around? Do you have any questions about that one? If not, I'll type to you on Discord. Yeah, it's kind of hard to call it one thing in particular to like really focus on. I think you just kind of need to go through everything. At least take like a passing look at everything, I'd say. But ideally, depending on your time, you should go deep into almost all of these sections. Like hyperbolic functions, you can probably skip. I don't think they cover hyperbolic functions. Everything else, I think, is potentially fair game. Applications of derivative, you might be able to skip over like Newton's method in business applications. You almost definitely can. Most of these other ones you're going to need, though. But yeah, and if you have any like specific questions on things you want to know more about, please feel free to ask. Let me type to Caden in Discord quick. Oh, Caden's computer crashed. Okay. So it kills. What else skills that you use a lot though? You think you're prepared for limits and derivatives? Yeah, I'll show the solution in a second. Just let me talk to Amorphous a little more. For integrals, integrals is really just the reverse of doing a derivative. So if you're ever not sure, just derive whatever you get and see if you get your original function back. So you don't need to do that much with integrals, thankfully, for AB. Thing I get comfortable with is U substitutions, which they're not always used like this, but at least in this context, they're pretty much always going to be used like the reverse of the chain rule. I don't, or maybe they are always the reverse of the chain rule. Maybe I don't remember, but if you have like a function and its derivative right next to each other, like this is where integration takes some technique. Like, I guess integration in specific requires the most practice, I think, because it can be really tricky. Taking the derivative is pretty procedural, and you can always kind of do the same steps. When you integrate, kind of all bets are off, and there's a lot of different paths to get to the same result. And it can be really tricky to spot what those paths even are in the first place. And it's very frequently that I'll try some approach and it'll turn out to be wrong and I have to back up and go to the original problem again. So integrals, specifically with U substitutions, are probably the top thing to get comfortable with. And Caden, let me show you the solution. Hey, Zeal29. We're a little bit in between questions right now. We're kind of like in the middle of wrapping two of them up. So we just had Caden asking the question that you see on the whiteboard there involving a triangle being defined by its coordinates, and you split the legs up into like thirds and you draw lines between them. It was basically a whole bunch of algebra to figure out if these 3 points are collinear, and we're able to do it. We're also helping out Amorphous, who's going to take the Calculus AB exam, which is like if you're not in America, probably that doesn't make sense to you, but it's like what like a 12th or 11th grader would take to get college credits early on. And they're asking kind of what they need to study to get prepared for that. So it's kind of the limits, derivatives, and basic integration. And then if no one else in chat has a question, I'm probably going to do a little bit more of, just self-studying for abstract algebra. I'm probably not going for a ton longer, though. Completing the square for integrals. Yeah, there might be some of that. For Calc AB, hopefully they don't go too far into that tricky stuff, but it's definitely possible. I graduated with a bachelor's in math, like probably coming up on 6 years ago now. I'm not currently studying as, like I'm doing some like self-studying for fun, but I'm not a student at a university right now. Grad school will be cool though. You're doing multivariable calc with proofs, just here to hang for a bit. Oh, awesome. Yeah, I've done multivariable calc, not the proofs part of it though. And even though I think multivariable calc is super fun, but I'm also kind of rusty on it. And so I always feel weird when someone just comes into chat and I start advertising to them. But if you're interested in math streamers in general, yeah, I highly recommend you check out the rest of the math community, including Penn Center. There's a whole host of people I can recommend highly who stream math. There's more out there than just that, but those are kind of the people who I know the best, I would say. So no need to do anything you don't want to, but I just like letting people know that those people exist in case you're ever interested in more like math streams. It's definitely more than just me, so. Okay, so I haven't seen Caden say anything in a minute, so I think I'm gonna assume that kind of questions are wrapped up from chat unless anyone new is coming with a new one. Grad school is a goal of mine. I'm not currently going to grad school though. I do have one of the best beers on Twitch. That's true. What do we say about limits and derivatives? Limits have a few tricky parts, but I feel like a lot of times they're kind of straightforward. You might have to do some kind of like algebra to simplify things. Oh, awesome, Amorphous. Yeah, it's always weird to advertise to people on YouTube that the Twitch streamers exist, because, like, what if they don't want to go on Twitch, but even if, like, one person hops over, I think it's worth it. So yeah, when it comes to limits, just kind of get used to playing around with things algebraically. And for derivatives, if you already feel comfortable taking the derivatives of functions, I would emphasize the word problems. They can ask about like related rates and things like that, I think, as part of the AB exam, which those can get kind of tricky. Over here in applications of derivatives. Oh, actually, are related rates not in the AB? I need to... Actually, the bomb, so glad you're doing this perfect role. You'd all be millionaires. I would take it. Yeah, basically, like my situation is I'm unemployed and I've been trying this just because I'm in a position in life where I can take that like risk to like try it out. Not expecting it to be like, you know, super good bet, but I really enjoy doing this. So even if and when I do get a real job, like I'm not going to stop doing this. I might need to change how I do it, but I'm definitely not going to stop. Yeah, exactly, Pen. That's why I try to avoid talking about like things that get a little bit too like real. If I'm on Twitch, I usually want to not think about the world. Oh, you should probably check out Pen Center's streams then. He's been doing some complex integration. If that's potentially of interest to you. Oh, okay. I'm going to advertise one more thing to you, Zeal. If you're interested in complex variables in general, Penn Center is actually doing a real complex variables course on Twitch starting in July. And there's potential for you know, current students to get a transfer agreement to actually get credits for taking that course. So that's something you want to learn more about, then I would definitely hop in Penn Center's Discord and check out the announcements section for all the information that's been announced so far. Beauty of calculator proofs of we are doing any calculations, we just set them up. Yeah, that's if your professor is nice, at least in my multivariable class, my professor was kind of nice, and they would just say to set up the integral without actually doing it. Oh, Stooky, hey! Hope your travels have been good. Penny boy. It's like the opposite of Dawn Father. I said I'm familiar with limits and derivatives. He meant you conceptually understand them, not necessarily in depth though, because you procrastinated so much. Amorphous, I would just go to that site and work through the practice problems, and that's the way that you're really going to know how much you do or don't know. Like it's like just like at least look through the problems and ask yourself if you think you would know how to do a problem like this. Like, do you know how to do limit as x goes to infinity of e to the e to the power of 2 minus 4x minus 8x squared? And if you would feel comfortable doing that, then just skip over this page or something like that. Because it's hard for me to like tell you what to do when I'm not like in your brain, I guess, knowing exactly what you do and don't know. That's what I always kind of struggle with questions like that. So it's not something that I can just tell you, something you have to kind of evaluate for yourself. Think you're extending for another weekend to go to the spring sectionals in Washington, D.C. Ooh, fair enough. These are some weird limits they have you evaluate, to be honest. How would you do these? It's like you get infinity, minus infinity, plus 0, minus 0. I'm just looking through this for my own benefit. Back to the term with the largest exponent. Oh, okay. Oh, yeah, that's fair. Yeah, so like you would take just the positive ones and factor out e to the 10x. Are you gonna have to do some L'Hopitals here, or? Oh no, you're just gonna get infinity. Okay. Paul really likes his exponentials on this page. Okay, here's some more like other examples too. Okay. Um, yeah, I just look through a bunch of sections of the site and see, and just try, ask yourself which ones you feel comfortable doing, which ones you wouldn't. But Ma, I need my dinner now. Yeah, no problem, Amorphous. And thanks, Penn Center, for helping out with that too. You ready to know? All right. Well, thanks so much, Amorphous, for the questions, and hope the rest of your day is good. I want to get an equivalence relation question, because I've never done equivalence relations in my life. How many questions are there? Oh, okay. Most of these are on number theory. Okay, here's our equivalence relations. Yeah, the only reason I'm not still doing the number theory ones is that I got bored of number theory. I really should be doing number theory for another like 2 weeks or something, and then thinking about equivalence relations, but number theory is so lame. I'm sorry. I don't like it. Oh, we got another Canadian. All right. I see you, Zeal. All right, Suki, thanks for lurking. Team Canada? Yeah. I think you guys are on opposite ends of Canada, though. Oh my god, that emote. um... UBC, Zeal of Ontario? Okay. Let S be the set of real numbers. I mean, I think 57 is also an equivalence relation thing, but I'm just gonna look at 58. Miss Alberta. Oh, so that's like right in the middle, isn't it? You basically already know them. That's what it kind of seems like. You're just the wording is so tricky. I guess would annex Buffalo. Well, I mean, we like let's do a trade. Canada can take Buffalo, and then America will take Penn Center. You know, it's kind of like shifting it a bit. Let S be the set of real numbers. If A, B belong to S, define... I don't... Like, how do you read this? Like, A squiggle B? Like, I was just saying tilde in my head, but, like, it's such an awkward, like, notation for me to actually, like show that what is an equivalence relation. Like, I'm just gonna call it tilde, I guess. Twiddle? I'm not calling that Twiddle. That's such a lame name. Twiddle? Oh my god. S is the set of real numbers. A is related to B if A minus B is an integer. Okay. Show that tilde is an equivalence relation on S. Describe the equivalence classes of S. Twiddle sounds like what Elon Musk was going to name Twitter before he came up with the Chad name X. It's not Twiddle. He wasn't letting him crazy America. Yeah, Fembox. Oh god, I hate getting too real on stream, but I feel like every place everywhere has problems, and every place everywhere has upsides too. And when you're in, I guess the grass is always greener on the other side. Although it's also fair to say that you as an individual prefer to live in this, like, other place too. Not to say that's better, but that it suits you more as a person. So, I don't know. I'm wondering how, like, the, because you could, like... Yeah, so because, yeah, I can see how 4 is related to 5, because 4 minus 5 and 5 minus 4 are both integers. Those have to both be true. Right. And I was wondering, like, if you have pi minus the decimal part of pi, or really, like, you know, any continuation of pi after a certain point, you can have some weird things like that, too, I would think. Might not have to worry about those. Okay, so, I mean, this is really more of like a... I don't think this will be particularly hard. It's more just getting the language right. So to prove that something is an equivalence relation, you have to prove three properties: that it's reflexive, which is A equals A, that it is symmetric, which means AB implies BA, and that it is transitive, which means AB and BC imply AC. Add notch whittle to my list of symbols. Oh my gosh. Notch whittle. Is it actually called twiddle? Equivalence relation. Wait, if X twiddles Y? No, they don't seriously call it that with a straight face. Yeah, I'd so much rather say tilde. Twiddle sounds like... I don't know what it sounds like. It's... Twiddle. They called me a madman. It's really funny. She didn't say anything, Mr. Anal Archives and Cox Theories. Damn it. Oh, Penn Center, after you went to get groceries, we went down a whole rabbit hole of dirty sounding math theories. So I think you saw the Cox-Zucker machine. There's a Cox ring. There's a Tits alternative theorem. Unrelated, there's a we went down a whole rabbit hole. And then someone was talking about, yeah. and there's literally a dude named Jacques Tits who made a theorem at some point. Slutskis, yeah. This is shit with the Cox-Zucker machine, yeah. And then the anal thing, or anus archives, was someone was talking about Anna's archives, and I guess I say Anna's like anus. And maybe there is also an anus archives out there. Lipschitz continuity. No, actually, you know, that one I've heard of though. Lipschitz. I honestly, that one, it's at least, it sounds more like a real thing. But yeah, Lipschitz is definitely up there too. How could we forget? Okay. So this one, I don't imagine this will be particularly difficult. It's just working our way through the actual, like, language here. So they just got very sus. It's been a good day. Lots of laughs. God, this problem was the worst. So I don't think we really need to go through specific cases here. We just need to, I think all the properties deal with things already being in the set as a given, so you don't need to worry about, like, the weird case I was saying, like pi minus, you know, some continuation of pi after a certain decimal. Like, you don't need to worry about how to express numbers like that. Come on. Okay, you're getting sprayed. Bad whiteboard. Okay. So, we're saying that S is a set of all real numbers, right? And that we're going to define or an equivalence. Chalkboards FTW? Hell no. Should head over to Zach's stream if that's how you feel. Oh, it might have to be one word, Pen Center? Like, my whiteboard's a little bit annoying because it doesn't like erase too well, but I can't stand the feeling of writing with chalk. It just, it makes me cringe. You have a beautiful big chalkboard in your tutoring center, you hardly use it. That was the price a little, yeah. I don't know if I have a special alert for 69 bits. I should really look into that. I have a bunch of alerts for things that are more than $1. It's like I have one for like pi and for the golden ratio and stuff, but I don't know why I didn't think of to make one for 69. Straight on scrap paper. Yeah, when I worked in a tutoring center, they had these like tiny whiteboards that I would walk around with. I think that's the main thing that I used. So we're gonna say for an A, B, in S, that A is related to B if A minus B is an integer. Okay. So let's prove this in equivalization. So we have to prove the reflexive property. So if we, that means I'm trying to like how to phrase it, but I mean, like I know the idea is A minus A equals 0. 0 is an integer, which means A is related to A. I guess that's how you would say it. The clip of me saying Cox Zucker machine. That looks good. Okay, thank you, Pen. Honestly, that's not a bad idea. Symmetric. I don't know why I'm writing out property. So for this, we're given, or I guess we assume is a better word. Assume A minus B is equal to some C that is an integer. Now we look at B minus A is equal to negative A minus B, which is negative C, which is still an integer. That's not how you make integers, is it? Because if C is an integer, then negative C is certainly an integer as well. Now, transitive. So now we assume should we do like A1 minus B1 equals, well, no. A minus B equals C, which is an integer, and I guess we'll do D minus, no, sorry. It's, actually, how would you phrase it? I think it wouldn't be that same C, it would be some other thing. Like that. And we would want to examine A minus D. And I think we do a plus B minus B thing. So A minus D is equal to A minus b plus b minus d, because we're only adding 0 here. And we know that a minus b is something and b minus d is something. So it's c plus e, and the addition of two integers is certainly an integer. So I think that's all we do for 58. Heck yeah. I see I missed a lot of things in chat, so let me catch up here. It's the first thing I've ever done with equivalence relations in my life. I love the way he says that. What did I miss? Pen center clipped. You would say twiddles. Embrace the twiddle. This proof looks like the proof of a vector space with the axioms. Oh, that like every possible vector can be expressed as a linear combination of those two vectors? I feel like it's different, but it's maybe like a similar structure for a proof. I think vector space, maybe you have to go a little bit farther. Maybe? That spans? Oh, I don't know then. Someone close to showing quotient spaces work. Okay. I don't know what those are, but I'll take it. Not Mathematica? Sodium Mathematica? Either way, thank you for the follow. It's gonna be me saying Cox-Zucker machine. All right. I'm gonna have to look at when I first said it, because that might be when the shock is more setting in. But I'll keep this one open. I want to see. Oh no, did it not? Oh no. Okay, yeah. Got him. Okay. Seal. Fair enough. After Algebra until quotient group showed up, and then those kind of fell off. You'll get to it next time. All right. To be fair, that's a lot farther than I got. Actually, you know what? I'm kind of curious. Let me go and grab it. All of my algebra knowledge until now came from this book, which is like, if you want to cram for the math GRE, this is how you do it. Let me look at their part in abstract algebra. Page 227. Somewhere around here. Where is it? Okay. This was the entire schooling on abstract algebra that I have. That thickness of pages. It's not a whole ton. I think I learned like almost nothing from this. And it goes all the way into group and ring theory too. Pretty huge topics for like just that. So I did like at best mediocre on that test. Was math Jerry prep books? Yeah, I mean, for what it is, it's a pretty good resource. You just the idea that you can compress these topics into something you can cram is a little bit like optimistic though. Quotient is a surjective map. Dozen chapters, for each chapter should be a whole text. Exactly, yeah. You think you have that book? Yeah, I mean, it's a nice book for what it is. Marhalis, thanks for the follow. I just think it can't, if you, unless you already have a background familiarity with the subject, you're not going to learn everything you need for the GRE from this one book, which is fair enough because these are huge topics. I only came with the familiarity of like calculus, a little bit of linear algebra, and differential equations. But like number theory, abstract algebra, analysis, topology. It covers topology. I don't remember learning about topology. Did I just skip over that chapter or what? I don't know. I probably did, to be honest. Yeah. Okay. Anyway. No one likes topology. I mean, I know I don't, but I also know almost nothing about it. Okay, let me put this book back and we'll do another couple of problems, I think, about equivalence relations. Tim, you try to do topology at blackout? I mean, to be fair, I did actually get accepted to a school when I was applying to grad schools. So apparently my GRE score wasn't that bad, but I didn't end up taking it. 59. Let S be the set of integers. If A, B belong to S, define RBs if A, B is greater than or equal to 0. Is R an equivalence relation on S? Prove a set is open using the sequential definition. I have no idea what that is. Oh, is that a topology thing? You scurry back to the Pokemon Center? Oh, actually, yeah. I remember for Zach's real analysis class, like, there are a couple of little topology like things in there, and that does, like, I remember like learning a little about like subcovers and covers and things like that. Math theory, because a friend of mine was taking it and you figured you'd try it too. Yeah, I'm getting a math PhD last year. Ooh, wow. Prove that a Clopin introspective set is emotionally unstable and inverted. Oh god. It's R an equivalence relation on S. So I would say that this is certainly reflexive because if AA is basically A squared, we're talking about real numbers, that's certainly greater than or equal to 0. Still saying a master PhD sounds too hard for me. That's more than I have. Got a second master's. My cousin has like 3 masters or something like that, and my family like gives him shit by being like, "Oh, how many masters adds up to a PhD?" It's really funny. My family also just like gives people shit, but it's like if there's a sequence whose tail is inside of the set, then it's open or something along those lines. Okay. All right, so I definitely agree this is it's reflexive. It's symmetric since multiplication is yeah, I mean it will be symmetric because multiplication is commutative. Is it transitive? That's a good question, me. So you have to have either both positive or both negative numbers, or 0. All right, see ya, Yanis. Hope you have a good night too. Get a 4th one just to mess with them. What levels of math are you at? Intermediate parts. Oh, did I tell you before? The only degree I have is a bachelor's in applied math. I think it's an undergraduate level abstract algebra book that I'm reading from. Yeah. what Penn Center says. You took one stats course, you never want to go back? Calculus-based stats, I didn't mind learning about PDFs and CDFs because I think that a lot of people's frustrations with stats is those arbitrary, like, why is the normal curve exactly like that? Why do we take 95%? And in calculus-based stats, you don't learn why we do that because it's arbitrary. But you do learn how to make your own arbitrary decisions and your own things if you wanted to, and it wasn't as bad in that respect. The stats department at the uni is basically famous for being garbage. Oh, okay, well that's a separate issue, but yeah. You had to take 3 Gs. Okay, can I convince myself that this is transitive? If I think so, because either, oh wait, well we should think about 0. Because -2 times 0 is greater than or equal to 0. 0 times +2 is greater than or equal to 0. But -2 times +2 is less than 0. So this is not an equivalence relation. Because 0 causes you issues. Otherwise, I think it would be. A dark time in your history. You failed stats 3 times at college. It was unused when picking it. Okay. Yeah, that's fair. Benbox. Do it do stats to not do it? Thank you, Benbox. Okay, I mean, I feel like these equivalence relations, I've only done 2 questions, so maybe I shouldn't get too arrogant. But so far, I'm having a lot easier time with it than number theory. Yeah, I was about to just call, like, to say yes, but I was like, oh, I probably should think about 0. 59 is not? Okay, good. All right, let's see what 60 is. You meant to tell me why? Oh! Arizo miss you thank you for the follow. Took over 10 classes in statistics. Really, Zone? Like, why, I guess? Like, is it something that you were emphasizing for yourself, or were you like required to by the department, or is that what you focus your studies on? PhD isn't. Oh, okay. See, no, that makes sense. Mathematical statistics. Also, you. Oh, all the stats bashing. Poor Zone Ranger. Yeah, I mean, if I wouldn't mind learning more about stats. I don't know if I'd want to get a PhD in mathematical statistics, but I think it's cool enough once you escape kind of like the high school level stats, like having to learn a million rules about each like distribution. Trading the MIT online free stats course, and it was hard. It's most of the language you had a hard time with. Now you've grown up a bit to revisit. Yeah, I mean, I did one like calculus-based stats class, so maybe I shouldn't talk, but you're gonna reread Wackerly at some point. Wackerly? That's a name too? We think of the Wizards of Waverly Place, that Disney Channel show, but with more whack, I guess. Best math stats book you've read? Wait, heard? Fair enough. I guess like read. Let S be the set of integers if AB belongs to S. Define RBs if A plus B is even. Prove that R is an equivalence relation and determine the equivalence classes of S. The linear algebra 2 term test marks a uniform distribution. That's not good, yeah. You know, better that than like exponential. You know, I think that's one that like starts high and then it levels off. Still not good though. A plus B is even. Prove R, determine the equivalence classes. All right, this one is going to be a whiteboard one, I think. Because the equivalence classes, I'm going to need to remember how exactly those, because those were kind of, those were kind of, I found a little bit confusing when I was reading about it. Okay, so S is the set of integers. I'm just gonna write colon because I don't know if there's a better way to write that. S is the set of integers. If A, B belong to S, why don't we just use Z? I wonder if there's a reason. I guess maybe for the notation later. Define A or B. A plus B is even. All right, so let's prove this is an equivalence relation first. So reflexive, A plus A is equal to 2A, which divides 2, so A is even. It's probably a bad way to write it, right? I'm just going to say 2A is even. I feel like that's obvious enough there. I just said obvious, but oh well. All right, so assume for symmetric A plus B is equal to 2K. Then B plus A is equal to A plus B is equal to 2K because addition is commutative. So that means A is related to B, implies B is related to A. And then for transitive, assume A plus B is equal to 2K, and we'll say B plus C is equal to 2L. Then A plus C. Ooh, what do we do here? Can we say A is equal to 2K minus B, and that C is equal to 2L minus B? Wait, there we go. And then we get 2K plus 2L minus 2B, factor the 2 out, and this is an even number? Is that how that works? Careful chat, we can use the notation to say B is related to A, or we get modded. Really? Bra? Oh, okay, you're making a joke. I was like, I hope you want to get banned for saying bra. For what year? These problems are similar to your first year proofs course. Something about 3 ways either. We still got to do the equivalence classes bit. That's why I want to do this problem on the board, but thank you, Finbox. Should just typically 3rd year. Okay. Oh yeah, so like the automata has like 4 different levels or something. I think when I first started streaming, I had it set to level 2, But then people would put math speak in my chat like 2 to the power of n and would flag it for bullying. And after having that happen like a million times, I was like, okay, I'll just set it to level 1. And now it catches basically nothing, which I think is better than catching everything. But yeah, the automat is weird with math speak. It doesn't seem to understand it. 3 ways to roll dice today and got modded. Yeah, I mean, if it just blocks a message, it always doesn't like ban them or anything. For misogyny? Yeah. Whoa, Pen Center, please keep that language out of my chat. You can't just say 3 ways to roll dice. You laugh so hard, yeah. So, what are the equivalence classes? Like that's what I always, or I mean, always. I've learned this like 12 hours ago when I was laying in bed and reading this. So, an equivalence class it's basically everything that's like, for an element A, it's everything that's equal to A. Or, related to A. So it's all even numbers and all odd numbers? Because we're talking about integers? So I guess we'd say the equivalence class of 2. I forget how you note it. Yeah, I need to look in the book for how you actually denote the equivalence class. That was me. God forbid we try to solve a combinatorics problem with that mod around here. 2 is equal to something? Okay. 2 is equal, and like you use like the set notation, right? 2 is equal to 2k for k belongs to integers? Like that's how we would express an equivalence class? And this would include 0 and the negative evens. And we're going to do the equivalence class of 1. We'd do 2k plus 1. I hope. That's my idea, at least. Because 2 evens add to an even, 2 odds add to an even. He said 4 ways you would have gotten banned. RB Baconators? Yeah, RB Baconators. Combinatorics easy? I wouldn't call combinatorics easy for me, at least. So that's my idea for how we would say this. Let me, I guess. If you want someone to talk to about combinatorics in particular, I definitely would recommend Ian Stuckey. But or like combinatorics in general, like I think Ian Stuckey is your person. But my own experience with combinatorics is like counting problems, and I hate those. Yeah, well, exactly. But combinatorics is more than just counting, as far as I know. So maybe there's a part of it that I would enjoy, but I don't like counting. Combinatorics Burninator of Twitch. Okay, this is the like how they noted. That's what I was like thinking of. So I think I did okay. Math guy said it's like counting. Yeah, it sucks. It's the worst. It's the easier of the up-year math courses, really. Interesting. It could be like a professor thing or something like that, too. Burninating the permutations. Peasants. Oh my gosh. I invented the card game mentioned Catherine, the combinatorics teacher. You know, I completely believe that. I mean, I didn't do the extrudables A. Oh, maybe. Okay, you know, let me actually slightly rewrite it so it matches at least how the book expresses it. Maybe my way is also right. I want to match how the book is doing because I'm new to this. So if k is an integer, I think we would say that 2 is equivalent, or 2 is related to 2k plus 1. 2. No one look at me. 2k. Then if k is an integer, is equal to 2k plus 1. I think it matches the book a bit more. Yes, yo, my thoughts are I know next to nothing about them. I feel like I'm not gonna like it, but I should know it. Like I I don't really want to study algebra in the first place. I just feel like I'm gonna need it, so that's why I'm doing all this stuff right now. Thanks for the work, Pen. Hey Ben, stop by, say goodnight. Oh my gosh, yeah, you need to get to sleep, dude. But I appreciate that. Thanks for stopping by. Hope you sleep well. Reese is whining more than you having to do topology. All right. Hope the walk goes well. You get fucked up your sleep schedule? Yeah. I mean, mine's been kind of fucked for a couple of months now. I mean, for me, a fucked sleep schedule isn't that bad, but it's still not where I want it to be. You don't know about mathematical symmetries, if this is a joke or not. I think that was serious. How would you do 6C2? It's related to that other one that we were talking about before, like 202 factorial or whatever. Yeah, so I've heard people talking about like algebraic geometry or stuff like that. And just from the like from how it's called, I have no idea what that actually means, but apparently like the algebraic part in front of that means that there's some kind of symmetry involved. And I feel like I've heard the word algebraic put in front of a bunch of different fields, so it seems like symmetries are pretty important in, you know, almost all parts of math. There's only one question on functions? Wow. Suppose alpha, beta, and gamma are functions. If alpha of gamma, which is going to mess me up, that's not multiplication, that's composition, is equal to beta of gamma, and gamma is 1 to 1 and on 2, prove that alpha equals beta. Really? You get to divide by gamma. It's clearly not composition. Actually, no, what you do, you subtract the beta gamma over to the other side, factor out gamma, and then you have gamma equals 0 or alpha minus beta equals 0. No, so if gamma is 1 to 1 and on 2, alpha is equal to beta. How would one go about doing that? Gamma doesn't need to be 1-to-1? Really? So 1-to-1, just to remind myself, means that no two inputs map to the same output. So like x squared is not 1-to-1 because it's reflected like that, or like it's even. On2 means that it covers every possible output in the image. It's like the set of all real numbers is the one that I'm used to when thinking about, you know, f of x equals x cubed. Take the inverse of gamma on both sides. The inverse of gamma will go like way on the outside though. That seems like it's probably the idea. I don't know. You have some weird like gamma inverse of alpha of gamma. I'm not sure what to do with after that. For right cancellation, you only need surjectivity. For left cancellation, it only requires injectivity. Oh. I don't know. This is right cancellation? I would assume because gamma's on the right. Okay. Scalar multiplication of alpha gamma. Alpha's a function as well. Unless I'm misunderstanding what you're saying, Zeal. This is a function alpha composed of with another function gamma. The notation that they use is super weird. I'm not sure if I'm interpreting you wrong. Yeah, exactly, Zeal. Okay, so yeah, if alpha was like a scalar multiple, that would definitely change the problem. Yes, I couldn't tell you why they do it like this, but they do. Trickiest thing about abstract algebra is getting your head around the idea that multiplication no longer has to be commutative. Yeah, that like thankfully like linear algebra kind of, I guess, like it's probably the wrong word to use, but like popped my cherry when it comes to that. But it's really gonna like trip me up in other contexts too, for sure. For, you know, it introduced me to the idea of non-commutative multiplication. You know, today's been a perverted enough day. I may as well keep using innuendos. It's like matrix multiplication. It matters what, yeah. Oh, you're not talking about alpha's literally a scalar, though. You're talking about scalar multiplication as an operation between two functions. Okay. Oh, Bob. I'm looking at 65. And this book uses, this is function composition. So this is alpha of gamma equals beta of gamma. Sorry, I think an alpha is literally like 2 or 3 or something. It's like surjective and injective, if those make more sense to you. Let me 1-to-1 means that each input has a unique output. And onto means that every possible output is reached at some point by the inputs. Alpha would be a function if you want it to be. Yeah, but that's how. Like, I think part of the more interesting problem is that if it is like a general function. Injection and bijection? Yes. Or injection and surjection, and bijection is both of those, I think. I forget. I never keep injective and surjective straight. Does the book say which one is which? It doesn't say it, I don't think. Apply inverse of alpha on both. We don't know that alpha is invertible though. Actually, wait. What are the conditions for the inverse existing? If it's 1-to-1 and onto, gamma is a bijection. Alpha is not necessarily a bijection. Okay, yeah, so they're saying, I'll scroll back on the problem. So 65 here. Yeah, so like, it's not as simple as just doing inverse gamma of each side, because, yeah. If alpha of gamma equals beta of gamma, then alpha must equal beta. I almost feel like it doesn't even use inverse functions. Like, I don't know. No, I don't know what I'm talking about. Onto every cat has a blanket, 1-to-1. No cat has 2 blankets. That's why I want all my math explained to me with cute cat metaphors. That's amazing, Fembox. Thank you. Alpha gamma is alpha of y of x. So if gamma inverse exists, since gamma is a bijection, you can compose on the inside like that? Is that allowed? The image is a set of all cats. Yeah, Bob, I was kind of thinking like, if they have the same behavior, then they should be the same, since every gamma of x is unique. But is that a proof? And if what Phobos says works, then I mean that's also really easy. But like, I feel like just sticking inverse gamma on the inside is, I guess I don't know why it wouldn't be allowed. I just haven't seen it before, so I guess it makes me uncomfortable for that reason. You can see how the book does it. Yeah, when I said like maybe we don't even need inverse functions, I was thinking like maybe something like what Bob was just said. You aren't allowed to stick things inside. Not the first time I've been told that. I was about to look at the answer key in the back of the book. Let me. But X being the domain of alpha. Okay, well, let me try following with Andrews's hint here. before I look at how the book intends you to do this problem. I forget how you would like notate the domain of alpha. I mean, I guess I could name, like, you know, alpha maps A to B or something, I guess. Probably easier to just avoid that, though. Drink a couple so you're going to sleep. All right, Bob, thanks. Sleep well. Hope your drinking went good. So let X be in the domain of alpha. Then alpha of X is equal to X. And so we want to somehow want to get to be beta of X equals something. Just writing down what we know. We don't know A is invertible. Like, how do we possibly... Like, the only thing to do here is take the gamma of each side. That feels like we could... Or like we could really, if we took the gamma and then took the alpha of each side, just to make things look horrible, what does that look like? Just to force a beta. I mean, that's beta of gamma though. I don't, like, how do we get to beta? We don't know what beta equals on its own. Oh my God, you're right, Anders. Thank you. I don't think, do we know alpha is on too? Is that implied by gamma being a bijection? I mean, gamma's on too. Oh, no, you're good. You want to get to beta of X equals something? I don't know, like we don't know anything about beta. We know things about beta of gamma. Fenvox is saying to look at a theorem on page 23. I think maybe it's 22, but you're probably talking about this. You know alpha of beta equals beta of gamma, so you need to make appear gamma inside the alpha that you started with. I mean, are we allowed? I don't think we're allowed to just... That's why I was doing like the gamma of each side and then the alpha of each side, because we can't... Or maybe we can, but I don't think we can just directly put a gamma inside of the alpha. Hey, SPQ. So the only thing here that I could think is relevant is this fourth property down here. But I feel like I know that's invertible, I just don't know how to imply the inverse function here. You can if you can justify why it's valid. Okay, interesting. Okay. And you're saying that we only needed to be on 2 here. So gamma being on 2 must be the justification for why we can arbitrarily get a gamma inside the input of a of x. Why? So if it's on 2, like it's not like you're gonna SPQ, I'll show you the problem. It's 65 right here. This is function composition, not multiplication. So this is alpha of gamma equals beta of gamma. Andrews is saying for this exact property, we only need it to be on 2, and the one-to-one is unnecessary. And I'm trying to figure out how we use on 2. Hey, Ben. Diagram domains and codomains show how they compose to see more clearly how the proof goes. Yeah, because I'm getting confused with how, like, what maps what to what set. Monomorphism? I don't... That's not going to help me, at least. Alpha... So alpha and beta... Okay, okay, yeah, Andrews, I think it's a good idea. Let's label what sets get mapped, or what functions map what sets to what. So I think the implied mapping, by how this question is framed, is that alpha, maps some set A to some set B. Beta maps the same two sets. And gamma has to map something to the input, and that thing could be anything else. Map C to A. That's what I'm imagining this works. Gamma is a to b. Oh, okay. You said it in a different way, but it should be left. Yeah, I mean, if it's left, it's really easy. You can just take the inverse gamma of each side. This one, I don't know so far. So we know that gamma is on 2, so every element of A, like I guess, gets mapped to by gamma. So there's no issues with being allowed to plug a gamma into alpha or into beta. Does that mean they have to behave the same though on its own? I feel like it doesn't. And I don't know what else you need to show in order to like make that work. We started with x in A, right? Right. Or, you know, x in alpha, which I guess x is also in A then. Okay, so um I feel like I understand intuitively how gamma... Well, actually, no, I don't. If x is in the domain of A, it's also in the range, I mean, of alpha. It's in the range of gamma. Um, I don't know. I understand that gamma covers every possible thing in A. I just don't get how that's helpful. Or at least it doesn't stop us. I don't know how to move forward with only that information. I don't know what taking the inverse... I don't know if being invertible helps. Or I don't know how it helps. And prove it is to note that since gamma is surjective, there's a section that is a function gamma prime that maps A to C such that gamma prime of gamma is just C. You can restrict gamma to the image of gamma prime. I don't know what that means either, I'm going to be honest. I I don't know how that's a proof either. Hey, Milk. Yeah, I'm probably going to wrap the stream with this problem if I can figure it out anyway. But this is a harder problem than I thought it would be. Okay, well, it seems like, you know, both you and Anders are saying that, like, we need to be able to... And no, you're completely fine, Bucks. We need to be able to justify right composing each side of a function, or each side of an equation. Basically, if we're going to put in linear algebra terms, with, like, right multiplying an inverse matrix. And apparently, being on 2 is sufficient to justify that. Let's just start playing with symbols. Like, what does this mean? Well, x is in A, x isn't in C. I feel like this is already not valid. Gamma of y is fine. Wait. No. No. I have it backwards. X is an A. So gamma of x is fine. Gamma of y is not fine. Because y is in B. And gamma needs to have... Wait. No, I mean this backwards. Dude, I literally, I can't keep this straight in my head. Alpha of x is equal to alpha of gamma of y for some y, since gamma is on 2. alpha of x is equal to alpha of gamma of some y? Y is in... But y is in B, and gamma needs C as an input. So I don't understand this statement. Actually, you're just saying for some y, I guess. You're using y in a different sense than I did. Y and C, okay. Okay, so this I think I can buy because gamma being on 2 means it covers every part of A. So no matter where alpha wants to map things, gamma can somehow, some way cover that. Okay. Okay, that I'm on board with. Okay. God. It's so simple but so hard at the same time. So we could do similar for beta. It would be a leap to use the same exact values though, I think. Like the same x and y. Let's get rid of that part because it's a little bit old. Okay, yeah, so I guess that implies alpha x is equal to alpha gamma y is equal to beta of gamma of the same input? I guess that's the advantage of using the O notation, because you kind of avoid that scenario. I think it's a different value. No, it should be the same value, I guess. I mean, knowing what the result should be, it should be the same value, but... Alright, I'm just going to do the same input and not question it then. It feels like a leap though, because like, and then we can do the same justification up there, which is equal to beta of x. I still have a hard time... justifying why those would be the same. But I guess that would be the proof if we can get over that part. But how do we know they map each input to the same output? Like, why isn't that alpha of gamma of y sub 1 equals beta of gamma of y sub 2? I guess, yes, if we're allowed to do that, then the proof is really easy. I just don't know why we'd be allowed to do that. And I guess this is the justification. And you're saying it can be. Well, what do you mean? What do you mean? Why? um, I just see the idea of composing on the right. I've never seen it before. Why not? No, I mean that's fair. Like, I'm not saying any of this of what you're saying is wrong. I just am trying to understand it. So, like, doing a right compose, it's disturbing to me, I guess. Although it can be the case you mentioned, the only thing we're sure about is that alpha of gamma is the same function as beta of gamma. So if we take the same input, we're going to get the same output. Well, they might. Well, I mean, if we're supposing, the entire point is to prove that alpha and beta are the same function, but if we haven't proved that yet, and we have to think about maybe. Like, I'm trying to figure out what my like how to express my like reservation, I guess, or like what I don't understand. So like, we have to, even though we know that alpha and beta are going to be equal in the end, we have to play along with the idea that they might not be equal. And so what if alpha and beta require different values from gamma to map to the same thing? No. It's completely fine, Anders. That's why I'm just like, I'm being quiet. So I'm trying to like figure out why I'm still not on board. And sorry, I want to SPQs and Fembox's comments more like carefully, but I'm just trying to follow on one train of logic at a time right now. So if alpha, no, you're all good, Fembox. Since bijectivity is overkill in a game would be surjective. Okay. I mean, to be fair, it's Anders who's like pointing this out, but suppose f and g are the same function. For any x, f of x equals g of x. Okay, I guess maybe I am making that too complicated. And you're saying that means that if alpha of beta equals beta of, if alpha of gamma equals beta of gamma, then for my particular case, with the y that I've chosen, you know, then those two y's should be the same. That's fair. Okay, thank you, Anders. Okay, like I mean that far. Now, how do we know that it's beta of x, the same x that was alpha of x? Which I know I was horrible. I'm sorry that I'm like being so slow here, but I guess now I'm learning about the last equality equal to beta of x. Why isn't it beta of some other input? Is it simple just x equals gamma of y? It's just x equals gamma of y, I think. Okay, maybe okay. I think I get it. I spent so long thinking about it that I feel like I don't even know now. Okay, yeah. Thank you, Anders, for pulling my hand through that. I should remember to give out saves, because I never remember to give out saves. And then let me also read more what Fenvox and SBQ were saying now that we've taken this to its logical conclusion, I think. Okay, so I think Fenvox's idea is a little bit shorter. So let me start with that. If f of 3x minus 7 equals g of 3x minus 7, what can you say about f of x and g of x? Then you can let z equals x plus 7 over 3. Oh, you have nothing to apologize for, Fenvox. My entire stream is me making mistakes. They weren't. Because we didn't use oh no to oh no. Yo, Waffle! Thanks so much for the raid. How's your stream? Punky Nennet? I'm saying, I'm probably butchering that. Welcome in. Thank you so much. Welcome in, everyone. Stream was stream. That's good. That's a tautology right there. Today we learned math is. Thank God I'm not the only one. I've been I got it right. Oh, good. I've been suffering on this one problem that should be very simple, but for me it's not. It's like some like function composition. And this notation is also super weird for me to get used to. And so I think we just kind of made sense of the proof that Andres was sharing. And so Femvox, you were trying to give an example to help me out. What would you do with your x equals, oh, you're gonna put that into the function again. Oh, it's like the inverse. Okay. I think I see what you're saying now, where you can always like, oh yeah, since the line is invertible, or actually does a line that doesn't go through 0, 0 have an inverse? Yeah, it does. Sorry. Yeah, you can always get back to f of x equals g of x, or f of z equals g of z. Okay. You're staring at 4 problems in chapter 1 of a math book? I mean, I probably made like a similar amount of progress in this math book here, so I definitely can't judge. But, you know, learning new things. SPQ. Right, call this abstract algebra. Yeah. I'm definitely feeling the abstractness. It says gamma is bijective. You can compose gamma inverse on the right. That's what I mean, I guess we've justified why you can compose on the right. It just gives me the heebie-jeebies. I just why I can compose on the right in this situation. Okay. I feel like you gotta go. Oh yeah, no worries, Waffle. Please take care of whatever you have to take care of. I'm probably gonna head out and raid on this in a minute here anyway. So, I appreciate the raid and hope you have a good after stream duties. It's a nice, yeah, it definitely is not. From C6 proof left cancellation with only injectivity. So that would be pretty difficult because you don't know that it's invertible. It's easier? Okay. You can probably make some kind of similar argument then? Or like like it's similar structured, but I don't know. Maybe I shouldn't bite off more than I can chew after struggling that hard with the proof of that one. Yeah, I think I probably, it's easier to see the steps. Oh gosh, am I actually about to do it right now? It's easier to, okay, you know what? As long as we're doing this, let's, you know, we'll do this and then we'll wrap up the stream. How about that? So, you know, I feel like as long as I'm on this train of thought, we should try and do everything we can, right? All right, so take the same setup, but alpha, beta, gamma are functions. Gamma is, you said injection, which is 1-to-1. Then gamma of alpha is equal to gamma of beta. I'm writing down the question and I made a mistake. You know it's bad when that happens. Okay. Like that. It's easier to see the steps. So I guess we'll do our same writing out kind of, we'll name the sets of the domains and codomains. Say gamma maps A to B. Alpha and beta map. I feel like I'm doing it in a bad order every time, but C to B. Wait, no, C to A. Because these are on the inside, so they need to map to the input of gamma. Okay, so I think that's valid, even if the lettering is awkward. Great, okay, great. So, I actually want to name another element. So here we didn't care about B. So I think we're not going to care about B here as well, coincidentally. So let's just arbitrarily say let X, we'll say X belongs to C, Y belongs to A. Why not? Okay, so we started with the outside here. So something we know gamma is 1 to 1, which means no cat gets 2 blankets. I'm using Femvox's cat metaphor. How does that help us here? So we can say, we make some similar statement like this. So, you only need 1 element. No need to take that y and a. Oh, really? Okay. Prove alpha equals beta. Okay, thank you for reminding me of that. It's 1 to 1 and on 2. It's implied they're isomorphic, right? You don't really get the question, if I'm honest. Well, I also don't get the question. I'm not doing a good job of expressing it, but if we're given this information, we want to show that alpha equals beta. And isomorphism and all that, I don't know what that means. For that one, we're given unnecessary information. We actually really need that gamma was a surjection or onto. So let x belong to C. So then alpha of x is equal to, don't we need something for gamma here? Oh, sorry, no, we want the other composition. Oh. Oh, wait, is that all we need? So, well, let's say the same x though. So we're doing left composing. Okay, this is a little more. It'd be so much easier if gamma was invertible. It's all about knowing where to start. Seems like it. Given a big hint that we only need to worry about an element of C here, which implies we just start with alpha of x, I would think. We could even... Oh. Wait, if it's injection, isn't our work done for us? Because if gamma maps... Maybe not. If gamma... Actually, wait, yeah. I feel like maybe this would directly imply that alpha of x... Oh, yeah. By injectivity of gamma. Because gamma has to map to a unique output. So if it's given the same input, it must be those two inputs were the same. Okay, I guess that is a lot simpler. Okay, I got there eventually. Gamma is putting on a blanket. If it's injection alpha has a corresponding beta. I think injectivity does imply a unique output, doesn't it? Or oh god. If injectivity is the same as 1-to-1, which is how I've been interpreting it, then it is a unique output. And I never keep injective and surjective straight, so I mean, heck if I know, but... The thing that a well-defined function has to be... It can't map the same input to two different things, which I think is different from what Hanyolo was saying. I don't know, but it sounds like I got to the right answer. So thank you so much, Andrews, for helping me through those proofs. Right, when I say... I imagine this exact diagram when I think of 1-to-1. I mean, on the left, because the other one is an example of not, but same thing here down with, same thing with on 2. A function can never map one input to two outputs, as far as this book is presenting functions at least. Oh, that's right. F of x equals f of y implies x equals y. That might be a more helpful way of thinking about it for these proofs. Okay, correct, Hanyolo. And it's basically like this diagram on the right here and in the upper right is not injective, because you know this A1, A2 both map to the same thing here. See, I've heard that, Andrews. I just forgot about it because I heard they would have to work with it like 1-to-1 and on 2 functions. Yeah, I was just like, saying it like, you know, maybe there's some other like, I was saying like functions as we've defined them, because maybe there's some other weird kind of math that has functions that doesn't have the requirement. I don't know if those would be particularly meaningful, but y equals x squared is not injective. Correct, Hanyolo, because of that like even symmetry. It maps different inputs to the same output. Actually, the book has a helpful chart. Like this. You can be one-to-one, you can be on two, you can be both, and you can be neither. They make it a little more complicated with playing with the domain and range, but you have the basic idea right there. I'll check out the book solution of 65? Okay. Oh, that's a nice way of thinking about it too, $10. Yeah. When you do that inverting thing, you have to make an arbitrary choice there. What? They didn't even say, like, right. I say, like, right apply inverse gamma. Because if I'm learning this up for the first time, I'm gonna think they mean left composing. I never even heard of right composing before today, and you guys helped me out with it. And I'm like, function composition is not commutative, so I'd be completely confused. Unless it is commutative in some weird way, but... actually, no, they specifically say it's... They make an example of it not being commutative. Or, you know, if it ever is commutative, it's a crazy coincidence. Or they're probably the same function. That's what's going to be in your future? It depends on what you study, Han Yolo. It's like I did applied math, and I didn't have to do anything even slightly related to this, basically. I mean, I did a discrete math class. You can feel it's building up to it already? Oh, well. For what it's worth, there's a lot of people who are really enthusiastic about this type of stuff. Yeah, the good old vertical line test. I like that because it's very like visual and easy to understand. I remember mentioning it in Zach's real analysis class, and there's some scenario where you can have a function that fails the vertical line test, but it still somehow works. I don't remember exactly the counterexample was though. It's on the vertical line test in the same way that I would think of it. Anyway, I think I've done enough math for one day. It's been 5 hours and 40 minutes. It's been a super fun stream today, though. A ton of laughs. So huge thanks to everyone who's been here, whether you're chatting or lurking. Let's go see. I mean, Penn Center's doing Legend of Zelda. I don't have anyone on who's doing math specifically. Is Penn Center? I guess go into back over to Penn Center. Twitch math streams for about 9 hours. Oh wow, Fenbox. Yeah, go eat some dinner and take care of yourself. / raid Penn Center. So yeah, I really appreciate everyone who's been hanging out with me. I'll be back on Tuesday with more math. Oh, I should stop the YouTube stream.